Yeah, hello. Am I audible?
Yeah, you're audible, right?
All right. So fine. Sorry.
Sumit, just a second. Yeah, before moving any further, guys, if you are not able to join the meet, don't panic. We have also shared the YouTube live stream link on the WhatsApp groups, so you can join in the WhatsApp group links as well. Okay, and we'll be taking attendance by circulating a G form for all the people who are attending the session through YouTube. So don't panic if you are unable to join the Teams link. There is also the YouTube link through which you can attend the session. All right. So yeah, we'll be starting right now. Sumit, you can begin.
Yeah, sure. Hi guys. Welcome to Summer School 2023 presented by AI Club. Now, firstly, the AI Club is a group club that was formed by two pre-existing clubs. That is the Analytics Club and the CVI Club, or the Computer Vision and Intelligence Club. The purpose of AI Club, as the name very clearly suggests, is a group of passionate students who are interested in the domains of artificial intelligence and computer vision and data science in general. We explore topics via projects like natural language processing, reinforcement learning, computer vision. And the purpose of Summer School 2023 is a way for us to sort of transfer the knowledge that we have over to you guys so that you guys can start from a very beginner friendly and very beginner level starting and eventually implement all of these algorithms and models, right? So we will be covering this in several sessions in the next few weeks, starting from very basic like introduction to Python, moving on to machine learning, then deep learning, and then computer vision, and eventually reinforcement learning, right? So these are the domains in which we hope to cover in the next few weeks. Uh, and for this is the first session. This is the introduction to Python, NumPy, and Pandas. It will be taken by myself, Sumit, and my co-presenter Srijit. This is the schedule which I assume all of you have guys have received. I'll let us say at the outset we are very happy as with the amount of enthusiasm and registrations that we got that shows that people have faith in this. And let us hope that they can have a collective learning experience together. I'll hand off the mic to Rutvik, who will explain how the Slido system works for this presentation.
Yeah, cool. So guys, you can scan this QR code. So as of now, I guess you guys might have realized that you're unable to chat on MS Teams. So to make this easier for us and also for you guys, we have introduced this Slido Q&A session. So scan this QR code. You'll be redirected to a Slido page where you can type in your doubts and questions. Okay. Sumedh and Srijit will be presenting, and they are the instructors for today's session. They'll be taking up doubts, and they'll be keeping a watch on all the doubts that are being shared on the Q&A page. Okay. Also, the people who are on YouTube, you can definitely post your doubts on the live stream chat. We are having coordinators there as well, who will be the moderators and who will be clearing all your doubts. So yeah, do scan the QR code and keep your Q&A page open so that you can ask your doubts immediately whenever you have any. I guess that's all from my side. Srijit, you can take up.
Yeah, all right. Thank you, Ritvik. All right. Hello, guys, and welcome to this year's summer school presented by AI Club. And yeah, let's get ready to learn. So today we'll be covering Python basics, and yeah, I'll be covering Python basics and matplotlib, while Sumit will be covering NumPy and Pandas. All right. So let's begin. So what is Python and why Python? So Python is a high-level programming language created by Guido van Rossum. And why Python? Well, mostly because the syntax is like very simple and it has a lot of libraries that makes your life much more easier. And when you import a library, each and every line in your code is going to be very powerful. All right, so we'll see how soon. All right, so now we first move on to data types in Python. So what are data types? So each and every variable you create in your in Python will have a specific data type. So each data type has a unique property. For example, it could be size or it could be how it looks. Like for example, your strings contain letters, while your letters and possibly numbers, but your integers contain only numbers and no letters at all. So yeah, we'll look at this in depth in our notebook as well. I hope the notebook is shared with you all. So yeah, let's move on. So yeah, most commonly used data types. So there are four most commonly used: numeric, sequential, non-sequential, and Boolean. So Boolean is true or false. So yeah, that's it. That's that. And numeric data types are They are integers, floats, and strings. And what's the difference between sequential and non-sequential? So sequential data types can be indexed while non-sequential data types can't be indexed. So what is indexing? Again, there's like a good picture which I'll show you guys in the notebook. So just remember for now that sequential data types are list and tuples which can be indexed, while non-sequential data types are dictionary and sets which can't be indexed. All right, so now operators. So what are operators? Like, yeah, so operators help you perform operations on variables and constants. And there are mainly three types of operators: arithmetic, comparison, and logical. So yeah, arithmetic is your addition, subtraction, multiplication, division, everything. Comparison is your comparing greater than, less than, or equal to something like that. And logical operators is your and, or, not, and all. All right, so now we'll move on. Yeah, so now we'll move on to the notebook. So if you guys have the link to the notebook, you can just click on it and then it'll open a page on your Google Colab. So if you're not logged into into your Google account, you can just log in, and there you can find a small thing called copy to drive on the top left of your screen. So yeah, you can just click on that and then you can have your own copy with you. All right, so now I'll be sharing my notebook and telling you guys, and yeah, showing everything. So yeah, this is the Python notebook that you are supposed to have. So I'll give you guys like a minute or so to copy down, like yeah, to just make a copy of your own notebook. So if you guys want to, or else you can just look onto my screen and I'll be running everything here. So now if you have copied everything, like if you copied your own notebook, so you can click on something called connect here. For you, it'll be connect. For me, it's reconnect. So you can just click on connect and it'll allocate some RAM and everything. So yeah, just wait for a second or so. Yeah, so as soon as it says connected, you're ready to go, and you can run stuff on your own laptop, on your own device. All right, so let's go. So now we'll start with the most basic of every programming language, outputting something. And in Python, if you want to output something, you just write print and brackets, whatever you want to print. And since this hello world is a string, you have to put it in quotes, or else if you don't put it in quotes, it'll throw an error. Well, now why do I have to put in quotes? Now this is something called syntax where you have to do it. Like your interpreter follows a particular set of rules, and yeah, so one of the rules is your strings have to be in quotes for it to get printed out. So yeah, and then if you guys are running this, there's a shortcut for running your cell. It's Shift Enter. So you can, as soon as you click Shift Enter, you can see that what's getting printed out is Hello World. All right. So moving on. So here you can see A equal to 9 and
Hello.
B equal
Yes,
to 3.
Srijit.
So yeah.
Yeah, just a second, Srijit. So can you guys react with a thumbs up if you are able to open the collab notebook and if you are able to make a copy of it? Okay, great. So I see a lot of thumbs up. Okay then, Srijit, you can carry on. If you guys are facing any errors, you can or facing any issues, you can definitely post your doubts on the WhatsApp group, and you can also post it in the Slido Q&A page. Okay, we are keeping an eye on that. So we will be clarifying all your doubts there. So as of now, we have shared 3 collab notebooks with you. You can open the first one, which is Python 101 part 1, and you can try to follow along as Srijit explains all this else. Okay? Yeah. Yeah, Srijit, you can continue.
Yeah. Uh, oh wait, can you see it now? Is it zoomed in now? Yeah, all right. Perfect. So yeah. All right, so now moving on. So I hope everyone is ready with their notebooks if they want to. Yeah, they want to run stuff. All right. So yeah, again, the shortcut is Shift Enter or Control Enter to run your cell. All right. So now A equal to 9 and B equal to 3. What are we doing here? So here, A equal to 9, we are declaring a variable A and also telling that the value of A is equal to 9 and similarly B equal to 3. So now we are writing a print statement here. Print square of comma b comma is comma a. So so here what I'm trying to do is I'm trying to print that square of 3 is 9. So as I've stored the value of b as 3 and stored the value of a as 9, I want to print square of 3 is 9. So how do I print that? So notice that I haven't put the b in quotes, because if I put the b in quotes, the interpreter is going to think that I'm trying to print out square of b is a. but I'm trying to print out square of 3 is 9. So that's why I end my quotes here and then put a comma, B comma is and comma A to print out square of 3 is 9. And yeah, so this is something interesting. This is called F strings. So if I don't want to put this comma B and comma A, then what I can do is I can write print and then I can write F before my string starts and then write the string whatever you want to output square of and then the variable you want to substitute the value for is and then the same thing again. So square of B in curly braces, these are called curly braces, and inside your B and A are your variables. So yeah, so square of B is A. So yeah, so let's just run this and see what happens. So we're getting square of 3 is 9, square of 3 is 9. That is these two lines are logically are equivalent. So square of B is A and square of B is A. So here the value of B is getting substituted, and here the value of A is getting substituted. Likewise in the previous line as well. So what are these green lines that you see? So these green lines are comments which are ignored by the interpreter, and if I write something followed by a hash, they are all ignored by the interpreter. So you can see that I'm typing something and they're all ignored, like they're all in green. So what this actually shows is that the interpreter is going to ignore this. So why do you write comments? Your comments is to improve the readability of your code and to also explain what you're trying to do in your code, like what I'm doing here. So like how I wrote, these are called F strings. Yeah, so I use comments for explaining stuff to people or to people to anyone who's looking at your code. All right, so now moving on to data types. So now x equal to 10, name equal to student, is it training equal to true, and decimal equal to 1.8. So I'm again declaring a couple of variables here, but as you can see, like even if you look at it, they're all different. Like this is a number, this is a word inside quotes, and this is just true or false, and this is a decimal value, while this is not a decimal value, this is just a whole number. So let's see what happens if we print out print x, print name, print is it raining, and print decimal. So yeah, you get exactly what you wanted it to come out as: 10 student true and 1.82. But yeah, all right, so now so now, yeah, now that you know that these are actually of different data types, so how do I check what data types these are of? So I will use something called type x. So something called this function called type and braces and brackets. So type brackets x. So what this actually does is that it returns the data type of x, and here since x equal to 10, so since x is an integer, this is going to return integer, and I'm going to get integer printed out, and that's exactly what you get here, class int. And then next, I'm printing out the data type of name. You get class string. So this str is short for string, and then this int is short for integer. And print type, is it raining? So you would expect it to be of string again, but note that this is not in quotations. And you also learned that as I shown in the slides, there's something called boolean values, and this is actually boolean. So true is actually a boolean, and this decimal equal to 1.82. Yeah, so as I told you, there's something called float as well. So there's a small difference between integers and floats. So integers are whole numbers, like without a decimal part in it, while floats are numbers which have the decimal part in it as well. So if I had written 10.0, it wouldn't have been an integer, but it would have been a float. All right, so now decimal equal to 1.82, and yeah, so as you would expect that to be a float since it has a decimal value as well. That is after the yeah. And then yeah, that's what I'm printing out the type of decimal and I'm getting as float. So I hope everything's clear till now. Yeah, as you can see, Python automatically detects every data type of the like detects data types of the variables, unlike other programming languages. So if you had experience in other programming languages like C or C++ or Java, you would know that you would have to type int x equal to 10 or character array name equal to student. But in Python, it's so simple that you don't have to tell what you're declaring, which variable data type you're declaring, but you just write the variable name equal to and then the value it has to have. So yeah, this is why people prefer Python a lot, because the syntax is very easy. But yeah, there's a slight trade-off there where Python is comparatively slower compared to other programming languages. Right, so now moving on. So this is something called typecasting. So typecasting is you telling the interpreter to treat this as an integer to suppose now you know that 5.6 is actually supposed to be a float. But when you write y equal to int 5.6, you are actually forcing you're telling the interpreter to convert 5.6 to an integer. So typecasting is basically converting something into an integer. All right, and int one is already an integer, so it's getting converted to an integer. So integer to integer, that's fine. And notice that this 20056 are in quotes, so it's supposed to be a string, but then I'm converting it to an integer by writing int in brackets and whatever I want to convert to an integer. And note that if you want to convert something like something like a word, like you want to convert hello to an integer, yeah, that's going to return an error for sure. So be careful. So you can convert only stuff like floats and doubles to integers, something like that. And yeah, so double is also similar to a float, just that it has more decimal values after that. All right, so now note that if I'm writing int 5.6 and I want to convert 5.6 to an integer, it doesn't this 5.6 doesn't get rounded off, but rather the decimal part is stripped away. That means this zero point 0.6 is just gone. So suppose I had a number 7.99999 and I'm doing int 7.99999. It is not going to be 8, rather it's going to be 7, because the 0.999 is going to get stripped away. All right, let's just run this once. Yeah, and that's it. So x will be 1, y will be 5, and c will be 20056. If you want, you can just check it out. So let's just do print z, and just do print type type of z. So yeah, see, this was supposed to be a string, but since you've converted it to an integer, now it's of the type integer. All right. So 1 second. Yeah. So now we have done operators as well. So operators perform processes on variables, constants, and the different kind of operators can be understood through examples. So as I've told you, there are arithmetic operators and then different kinds of operators like comparison operators and logical operators as well. So now let's look at arithmetic operators, where we'll look at addition, subtraction, multiplication, division, modulus, and exponent. So some of you might be familiar with all this, but I'll just go through it again. So print a plus b equal to a plus b. So yeah, here I'm declaring a as 5 and b as 6. And now I'm going to do some operations on a and b. So print a plus b equal to comma a plus b. Note that this is not in quotes, because I want to print out the variable that's returned after that. All right, so a plus b equal to a plus b, and b minus 2 is equal to b minus 2, and so on. So now a into 4. So notice that I don't put x or anything. For multiplication, the syntax is a star mark. That is shift 8. Shift 8 will give you star mark. All right. So b divides 3. Okay, let's actually just start guessing the values for this. So a plus b, I'm supposed to get 11, and b minus 2. So 6 minus 2, I'm supposed to get 4, and a into 4, that is 5 into 4, I'm supposed to get 20, and b by 3, that's 6 by 3, I'm supposed to get 2, and then a modulo b. So what is this modulo? Okay, so modulo is an operator which returns the remainder after you divide both the numbers. So now if I'm dividing a and b, so I'm dividing 5 by 6. So this is logically equal to 5 by 6. So after you divide 5 by 6, the quotient you get is going to be 0, and the remainder you get is going to be 5. So you can see that 6 into 0 plus 5 is equal to 5. So yeah, 5 divides 6, the remainder is obviously going to be 5. So that is exactly what is getting returned. A modulo b, that's equal to 5. So if I want to do power, so I'll have to do star star. That is telling the interpreter to the power of. So it's like 5 to the power 2, that's 5 square, that's 25. So a square equal to 25. Yeah, and these are your basic arithmetic operators. Now moving on to comparison operators. So this equal to checks equality. Yeah, and this checks inequality. That's your exclamation mark and equal to, and greater than is normal greater than symbol, less than symbol. And note that here, for greater than or equal to, it is not equal to and then greater than, but rather it's greater than and then equal to, like the symbol, the order in which the symbols come is very important. If you switch the order, then the syntax is wrong, so you will get a syntax error. And similarly for less than or equal to, first it's less than or equal to, so you can remember it like that. All right, so Yeah, when used in expressions, the truth value of the expression is returned because you want to know when you're comparing two operators, you want to know if it's true or false. That's it. So now A equal to 5 and B equal to 6. I'm again declaring A as 5 and B as 6. All right, so now let's look at the operations in order. So A equal to B, is 5 equal to 6? That means is 5 equal to 6? No, that's false. Yeah, and notice that I'm putting equal to and not equal to, because equal to is actually assigning a value, while equal to is for checking is for comparing two values. So you have to be careful here. If you write equal to, then it's not going to make a, yeah, it's going to, your A value is going to get assigned as B, but it's not going to return a truth value at all. So equal to will return a truth value. So A equal to B, yeah, 5 equal to 6, that's false. And B is not equal to 2. This exclamation equal to, as I told you, is not equal to. So 6 is not equal to 2, that's true. And A greater than 4, 5 is greater than 4, that's true. Okay, so on. All right, so as I told you, the type that returns after you compare two operators is a Boolean. So let's just verify that. So print type of A equal to B. So I know that this is going to return a Boolean value, that is false. So type of false is what? Boolean. So that's exactly what I get here, a Boolean class. So yeah, so every time you compare two values, the truth, so you get a Boolean outside, like a Boolean value is returned. So that's one thing you have to keep in mind. So now logical operators. So I hope you guys have learned truth tables in your 11th and 12th, your basic and, or, and not. So there are truth tables for and, truth tables for or, and truth tables for not. So yeah, so we'll be looking at we'll be looking at and, or not here. So A equal to 5 and B equal to 6. So again I'm declaring A value and B value, and then I'm printing out A less than B or A equal to B. So again I would expect a boolean to be returned and a boolean to be printed out, and yes, that is indeed what happens. So let's just run this and then let's see what happens. So let's just go through this. A less than B or A equal to B. So is B, so that is 5 is less than 6. This is true. So let's just write it down. This is true, or, and A equal to B. So is 5 equal to 6? That false. That's false. But you know that for the truth table of truth and false in an or truth table, it's true. So that's what you get out. You get true here. And now again, a less than b, that's true, and a plus b equal to 11. So 5 plus 6 is equal to 11. That's indeed true. So true and true, that is your true. That's going to get, that's true again. So not of a less than b. So that is basically not of a less than b, that's true. Not of true is what? False. So that is exactly what you get. So these are your basic basic logical operators, and, or not. And now this is actually something very interesting. So now what do I mean by a equal to none? So I'm telling the interpreter that I'm declaring a variable a, but right now it has no value, so it's basically null. The value of a is null, so it's nothing. So what is stored inside a? Nothing is stored inside a. And now I'm declaring a variable b that is equal to a or 4. So now you know that a it has no value, while while 4 is actually a proper number. So now if I'm assigning a value to b, that is a or 4. So since a is nothing and 4 is like a proper number, b gets assigned to the value 4. So yeah, that's exactly what you get. B is assigned to 4. What is the value of b? That's 4. So yeah, you should know that b is equal to nothing or 4. A chooses 4, so b equal to 4. So now yeah, let's move on to our slides. Yeah. Before that, we have a very small quiz. So if you guys can scan this QR code, or I'll be showing it again. So it's a very small quiz. It has only like 2 questions, and there's like mostly like true or false or fill in the blanks or stuff like that. It'll be yeah, multiple choice. So I'll just be sharing this. All right.
Yeah, wait for 10 seconds, Srijit, so that people can scan the
Yeah.
QR code.
Yeah.
And also
Sure.
after
So
the
you can
quiz,
just
also after the quiz, once have a look at the Q&A and try to take up some questions.
yeah. So you can scan this QR code, or you can go to slido.com and type in this code 3551186, and there you can join the quiz and take the quiz. And there are only two questions, so yeah, I advise you to do it. I mean, it's for fun anyway, so just do it. All right. So I'll give you guys like a minute or so, and then we'll start the quiz. Okay, so why is none or four is four? Because none is basically none represents a false value. So false or something that's true, that is, it takes the truth value. So the true value here is four. So four gets assigned to your variable that's b. Yeah, I will be explaining about tuples, lists, and everything soon. All right. Yeah, and that'll come in the further part. Yeah, I'll be explaining that. Yeah, what is typecasting? I mean, I've explained it to you. It's like okay, none of four. Okay. It doesn't return a boolean type. Rather, it returns four because four is the true value here. I mean, it represents a true value because none is nothing. Okay. Alright. Yeah, I'll be starting the quiz soon. So let's just wait for a couple more minutes, like a minute or so.
Yeah, I guess you can start the quiz, Srijit, and then you can take up
All right.
the doubts later. All right.
All right. Fine. Yeah, I will be explaining built-in functions. Yeah, I'll be explaining functions as well. I'll be explaining everything. All right. Let's start the quiz. All right, guys. Let's just wait for a couple more seconds. People are still joining. All right, guys, let's start the quiz. Okay, so each question you'll get around 45 seconds or so. Okay, actually, I can see more people joining actually, so let's just wait for a while.
Yeah, Srijit. I guess it's fine. You can start the quiz.
All right, fine, we'll start the quiz. You'll have 45 seconds or so to answer. Okay, let's start. So identify the data types of hello, true, 0.008, and 5. So you can you can choose an option, and yeah. Okay, come on, guys. You have like 4 seconds left. Just you can just answer it. So time's up, and then string, boolean, float, and float. Exactly, that's right. So why? So hello, it's in quotes, so that's string, and this is true, so it's boolean, and 0.008 that's a float, and 5.0 that's again a float. And so now we'll move on to the next question. Yeah, and the correct answer is string, boolean, float, float, as I explained. And now, yeah, so Swati has can do it for the next question as well. Let's look at it. What is the truth value of this? Okay. So yeah, again, true is 1 and false is 0. Yeah, and then alright guys, so the majority I've seen is true. So let's just look at the right answer. And yes, that's true. So now 1 and 0. So let's look at it. So we'll go to the innermost bracket, that's 1 and 0. So 1 and 0, that's going to give you 0. And then 0 or 0, again the truth value will be 0. So then not of this whole thing is going to be not of this whole thing, that is not of 0. So not of 0 is 1, and 1 and 1, that is going to return true. So yes, indeed that's correct. And let's look at okay, someone, and yes, he's done it in 17 seconds. Okay, that's good. All right, so now let's move on back to our slides, and now we'll look at conditional statements. So how are the okay, what happened? Oh good, okay, oh, all right. So this right, I know C++ is Python syntax confusing. No, it's not confusing at all. Python is much more simpler. And when I type b equal to 5 or 4, then it printed 5. Why? I think because 5 is the first value that you're trying to assign it to. Because you type 5 b equal to 5. If you type b equal to 4 or 5, b would get assigned as 4, I guess. Because it won't check the second one. No, it won't check the second one because you wrote b equal to 2 or 4, so it takes this thing. None is a Boolean type. No, no, no. What I meant by none was you can't figure it out. Okay, that option might have been confusing, but no, none is not a Boolean type. My bad. Only true or false is a Boolean type. So why zero or none returns none? I mean both are false, so it returns none. So I think that's just a syntax thing. So I don't think there's an explanation for that. If there exists, I'm not sure about that actually. So okay, yeah, Python syntax is much more easier. Okay. Okay, yeah, guys, don't type your answers here. Rather, I think when I start the quiz, you can click on the right option there. Yeah, I will be explaining everything soon. Yeah, but then if I don't put it if I don't put it in quotes, then it doesn't become a string. What is integer in C++? The same as integer in Python, as I've explained here. Is Python important for AI? Yes. Like majorly you use Python for AI itself. So basics in Python is pretty important. We're learning, yes, you will learn NumPy and Pandas in this session, and an introduction to Matplotlib as well, if we have time, or else will be taken in the next session. And then special kind, how to print variables like today's date, etc. I think you just have to store it as a variable and then again print out the variable. Okay, I'm getting a lot of none is a string only. Okay, I'm not so sure about that. So if A is none, then what's its type? Okay, that's a good question. We can actually check it out. Okay, let's actually check it out. Okay, so it says if B is none, what's its type? What's its type? So let's just check it out. Print type of A. So and then let's see what happens. So yeah, it's something called none type. Wow. Okay, so that's insightful. So thanks for the question. Good question. Yeah. All right. So yeah. Okay. So I think I'll just resume teaching. So yeah, I'll take your doubts again after the next quiz. There'll be yeah. So we have four quizzes, and then they're all pretty small, just like this. Three quizzes, they're all small, pretty much like this. There's going to be two or four questions. That's it. Yeah, and then the notebooks will be containing them as well. So now we'll continue with conditional statements. So conditional statements are used in decision making. The three keywords used in conditional statements are if, elif, and else. Okay, so elif, you can, as you can see, it's just like elif is equal to else. It's like a mixture of else and if. So it's like if, elif, else. So yeah, let's move on. So what? So we'll be so there's something called loops as well. So looping means repeating something over and over until a particular condition is satisfied. And there are two types of loops in Python: for loop and while loop. Yeah, there are other kinds of loops as well, but these are the most commonly used loops. So there are for loops and while loop. So you use for loops when you know the number of iterations, and you use while loop when a given condition has been satisfied, and then that's when your while loop gets terminated. Right? So when the number of iterations is not known, the loop is terminated based on a given criteria for a while loop. Right. So functions. So here we'll be learning about user-defined functions. So functions are modules of code that accomplish a specific task. A function executes only when it is called, and a function usually takes inputs, processes it, and outputs or returns a value. And once a function is written, it can be used any number of times. So I'll explain the uses of functions in the notebook. It's much more easy to learn it that way. So you can see that why you use functions. Why can't you just write down the piece of code again and again? So yeah, that's actually one of the reasons. You don't want to you don't want to keep writing the same piece of code again and again. So use a function to make your code look much more neater. And yeah, so let's move on to our notebook. And then yeah, here we have conditional statements. Yeah. So yeah, conditional statements are used in decision making. So now I have declared a variable called is it raining, and I'm assigning it false, so it's going to be of the type boolean. And if is it raining, print oh no I can't play football now, else print let's go play football. So this is the syntax of your basic if else loop. So if so this is so print oh no I can't play football now is going to get printed only if this value is true. So if is it raining is true, then print this, or else print let's go play football. Okay, so now let's look at is it raining equal to false. So now as this is false, so if this is false, so it won't print this, rather it'll print the other statement else. So it's just like basic English. So if this is true, then print this, or else print this. So since we know that it's raining, so if is it raining, that's false. So it's not raining. So oh no, I can't play football now, won't get printed, but rather let's go play football, that'll get printed. So let's just check it. Let's run the cell and just check it out. So yes, that's exactly what's getting printed out. Let's go play football. As is it raining is false. So this condition is not satisfied. So this line won't get printed. Rather else and print let's go play football will get printed. All right. So now moving on, we have summer equal. I'm declaring two variables again, three variables: summer, winter, and rainy, and I'm assigning the Boolean values. And summer equal to true, winter equal to true, and rainy equal to false. So if summer, so now we know that summer is true. So this value is this thing is going to happen. That means I'm going to print out let's eat ice cream. And now you know that winter is also true, and that is elif winter. Let's play with snow. So you would expect let's play with snow also to get printed out. But the thing with if elif if else thing is it it looks for only one condition to be satisfied. It doesn't care about the rest of the conditions. So if so since this condition, the first condition itself is satisfied, it won't look at the other conditions at all. It just comes out of the loop. So you won't. So let's play with snow won't get printed. So yeah, let's run it and just check it out. Yeah, now as you can see, if summer, let's eat ice cream. So yeah, that's exactly what's getting printed. But you know that winter is also true, but this doesn't get printed out. Okay, so yeah, that's how it is. So if you want to change this, you can look at it again, false. If you change summer to false, then this if summer, this will be false. So print let's eat ice cream won't get printed. Rather, Okay, next it's LF, winter. Let's play with snow. Only that gets printed. So we'll check that out. Let's play with snow is getting printed out. So yeah, our logic is correct. Alright, so loops. So suppose you wanted to print this line, welcome to summer school 7 times. So yeah, this is one way to print it. Yeah, for sure, this is one way to print it. Welcome to summer school. Yeah, it's getting printed out 7 times. But then what if there was a more efficient way? Yes, there is actually an efficient way. It's called loops. So yeah, for loops, while loops, they help you. Yeah, you can change your code into a much more what do you say, better way. Like it's more sophisticated as well, and I mean not so sophisticated, but yeah, it's pretty good. It's a pretty decent practice. Instead of printing something like this, you can use a for loop or a while loop. Okay, so now let's move on to while loops. So yeah, this is the basic syntax: a while, and then the condition inside, and then followed by a semicolon and statement. Yeah, and then you should note that even for if summer, there's a semicolon here, and this is the syntax. So you cannot, you have to follow syntax. If you don't follow syntax, you get a syntax error. So yeah, after every if, elif, and else thing, there's a colon, and yeah, same for while. There's a colon here, and this is the condition that has to satisfy for while, so for it to go inside the while loop. So you could think of this as like a gate, and only if this gate is like if this is satisfied, only then it can go inside. Okay, so now let's look at it step by step. So now I'm declaring a variable t equal to 0, and yeah, since I'm using it in a while loop and incrementing it as well, so I can call this is also called a counter variable. So this is, yeah, just for you to count the number of times you want to run something. All right, so now while t less than 10, and then this is the condition that I am imposing, and this is the colon, the normal syntax. I'm going to print welcome to summer school, and I'm ending with this. So what is this? So you guys know till here, welcome to summer school, it just gets printed as welcome to summer school. So what is this end equal to dollar? This end equal to dollar is nothing but I'm telling the interpreter to print dollar after every time I print welcome to summer school. So I will get welcome. So what is going to get printed out is welcome to summer school, and then equal, and then dollar at the end. So welcome to summer school dollar. So that's what I'm going to get printed out. So now I'm incrementing t as t plus 1. So now since I've declared t equal to 0, t is going to be 0 plus 1. So t is going to be equal to 1. So this is one way of assigning it. There's one more way of yeah. So yeah, this is one way of assigning it. So t equal to t plus 1. So it is going to happen till this condition is satisfied. So now you can see that after one iteration, so iteration is the number of times it goes through this, like the number of rounds it takes here. So now t equal to 1. So now we know that after the first iteration, t is going to be equal to 1. So still 1 is less than 10, and that is going to be satisfied. And then again 1, so this thing is going to get printed out, and it's going to be t equal to 1 plus 1. So t equal to 2, and still 2 is less than 10. So this thing is going to get printed again. So this thing is going to get printed till t is equal to 9. So when t is equal to 9, you get t equal to 9 plus 1, t equal to 10, and then while 10 less than 10. So 10 less than 10, that's false. So this doesn't get printed out. So you can actually count the number of times you're actually printing welcome to summer school dollar. So it's going to start from 0 and it's going to go till 9. So 0 to 9, there are actually 10 numbers. So you're gonna print welcome to summer school 10 times. So let's just run this. And this is actually, I'm printing welcome to summer school 10 times. This is 10 times. And yeah. And yeah, the dollar symbol is coming because I'm ending the print statement with the dollar symbol. So yeah, welcome to summer school, and then there's a dollar there. And this piece of string is going to get printed 10 times. All right. So now moving on. We move on to for loops. The for loop
Yeah,
has the
Srijit.
following form. Yeah.
Yeah, just a second. For everyone who is attending the session from YouTube, we are sharing all the we are sharing the G form for attendance. Okay, the moderators are circulating the G form on the YouTube chat. So do fill the G form before we close it. Okay. So for the people who are on MS Teams, you need not worry. We'll be getting an attendance report at the end. But for the people who are attending the session from YouTube, it is compulsory for you to fill the form in order to consider your attendance for today's session. Okay. Yeah, Srijit, you can continue. Thank you, guys.
Yeah. All right. So moving on to for loops. So the for loop has the following form: for I in range 5 0 minus 1. So what is this range thing? So this range is actually, the syntax for the range is this: initial value, final value, and increment. So 5 comma 0 comma minus 1. So what is going to happen here is I'm going to go from 5 to 0 with minus 1, increment as minus 1. So it's going to be 5, 4, 3, 2, 1. And it is going to stop at 1, as in the syntax for range, the 0 here, the final value is going to get excluded. So I'm going to get, so let's just print it out and see what happens. Yes, I'm going to get 5, 4, 3, 2, 1. 0 doesn't get printed because the final value is excluded, and 0 is the final value. So 0 is not going to get printed out. Yeah, and it is going in the reverse order because I have put increment as minus 1. So this is why you get it like this. All right. So for loops with an else block, yeah, this is something a lot of people don't know, and it's actually used very less. So yeah, let's just skim through it like really quickly. For I and T and P, print I. So yeah, you print T and P, or else print for loop for loop else statement successfully executed. So as there is no break statement here, everything gets printed out. So for I and T, in T comma P, print I. So I is now first equal to T, and then I is equal to P. So T gets printed out and P gets printed out, and then your since there's no break statement, it just goes on further. So else print this. Okay, and then next we'll look at the same code, but instead we'll put a break statement here, something called a break statement. So what do you expect, guys? So for I in TP, print I and then break. So let's look at it like step by step. So for I in T and P, so I is going to take the first value as T. So it's going to print out I, that is T, and then it's saying break. So what is this break statement? So break statements are statements which help you to get out of the ill of any loop or any conditional statement. It just comes out of the loop. So nothing is going to get what do you say? Nothing is going to be get run after nothing is going to run after you print out your break statement. So after you print out your break statement, it's going to come out of your loop. So since this is a for else loop, this else statement won't be executed, as well as your second iteration for your for loop, because you have a break statement. So let's check if it's correct. Yeah, and that's right. So only T gets printed, and then P doesn't get printed because you have a break statement. So it starts with T, and then there's a break statement, so it comes out. So nothing else is getting printed out except T. All right. So nested loops. So nested loops are basically loops within loops. So okay, let's. So with I will declare a variable called x that's equal to 4, and then for I in range 1 to x plus 1. So yeah, what is this range? So x plus 1 is equal to 5. So basically your range is 1 to 5. So remember that your final value is going to get excluded. So the values I can take will be 1, 2, 3, and 4. Your I equal to 5 won't be possible because because 5 is excluded in your range. All right. So now as you can see, there's a normal for loop, and then again inside that there's one more for loop. Yeah, and that's exactly a loop within a loop. So yeah, this is what it is. And print j and equal to this. Okay, so let's look at this in a step-by-step way. So now for I in range 1 to 5. So first I is going to be equal to 1. And now for j in range, it's going to be for j in range 1 to so 1 to 2, the range is 1 to 2. So it takes only 1 because the final value is excluded. So it can't take 2. So it's going to print out only 1. So okay. So the next value for I in range 1 to 5. So I is going to be 2. So I is equal to 2. And then for j in range 1 to 2 plus 1, that's going to be 3. For j in range 1 to 3, that is, so j can take the values 1 and 2. So it's going to get run. It's going to run twice, and it's going to be print j. So it's going to print 1, and then it's going to print 2. And this is your again end with nothing. So you stick it together. That's what it means. All right. So next it's going to go all the way till 4. And then for j in range 1 to I plus 1. So since I is equal to 4, for I in range 1 to 5. So yeah, this is the last case where since I can take values only from 1 to 4. So yeah, finally it's going to take the value x equal to 4, and then x plus 1 equal to 4. X plus 1. Yeah. So I plus 1, that is 4 plus 1 equal to 5. So now j can take the values 1, 2, 3, and 4, and the fifth value, that is as your range, your final value in your range you excluded. So 5 won't be taken. So print J, it's going to be, yeah, it's going to be print on 1, 2, 3. So yeah, since, yeah, so if you combine all of your iterations together, this is exactly what you get: 1, and then the next iteration 1, 2, next iteration 1, 2, 3, and your final iteration, that is when I is equal to 4, it's going to be 1, 2, 3, 4. So yeah, so you get this beautiful pattern right here using this loops within a loop. Yeah, loops within loops. So yeah, this is nested loops. All right, so functions. Let's yeah. So functions, these functions are like so functions in Python are very important. You'll be using them a lot in machine learning, in AI. So yeah, so let's just look at this. This is the syntax for defining a function. So def, this means define. So that's like short form for define, but you can't write define there. You have to write def. So def, and then the name of your function, and in brackets a comma b. So your a comma b here are called parameters. So yeah, and then you have this colon. That's a syntax, and return a plus b. So yeah, there's yeah. So returning a value just means it just actually returns the value. It means like it just gives out the value, but it doesn't print it out. There's a subtle difference between return and print. While print puts it out on the screen, return doesn't put it out on the screen. Rather, it just returns the value. So we'll see what that means here. So all right. So yeah, return a plus b, and then I'm doing add nums 2 comma 3, and yeah, this is so a is equal to 2 and b is equal to 3. So I'm returning 2 plus 3, that is return 5. All right. So I'm printing out the value add nums 2 comma 3. Yeah, so this thing is going to be yeah, atoms 2 comma 3. So it's going to call this function. So let's run and check what happens. Yeah, and file getting returned. So this is a very simple function. All right, so now let's look at this. So yeah, I mean this and this, these pieces of code are like very similar, right? I mean, why do you have to define a function for this simple thing when you could just do it in 3 lines? This was like 1, 2, 3, 4. This was like 1, 2, 3 lines, but this was like much more complex than this. So you could just do it in like a simple way in 3 lines. But so why do you need functions? So yeah, why? Yeah, let's yeah. So suppose you want to define a function if yeah, which checks if a number is a given number is even or odd. So, okay, let's define the function. Let's call it odd even, which takes in the parameter num. So yeah, it's a parameter. It can be, yeah, it's a number. So you have this colon, and then we have a if else block here. So if number modulo 2 equal to 0, then return even, or else return odd. So what is this num modulo 2? So if if you have a number and then you divide it by 2, and then you get the remainder as 0. That means what? That means 2. That means the number given is a multiple of 2. That means the number is even. So return even, or else return odd. I mean a number can be either even or odd if it's a whole number. So yeah. So yeah. So this is how you define a function. And then yeah, this is how you call the function. So print odd even 4. So your num is going to be equal to 4. So if 4 modulo 2 equal to 0. So what happens when you divide 4 by 2? You're going to get the remainder as 0. So yeah, so this is satisfied. So it's going to return even, and even is going to get printed out. So let's just check it out. Yes, so 4 is even, 6 is even, and 5 is odd, because 5 modulo 2 gives you a remainder of 1. So if yeah, that's not equal to 0. So yeah, so it's going to print odd. Right. So if you didn't have this function, if you didn't have functions, then this is how your code would look. You would have to write this piece of thing. You have to write this thing like 3 times, and you can see that. I mean, it gives the same output, but then just look at the lines of code you had to write if you didn't have a function. A function is like much more easier to do everything. Yeah, it makes your life much more easier. Yeah. All right. So now let's continue our slides here. Right. Oh yeah, yeah. Before that, yeah, let's have a small quiz as well again. All right. So now I'll be sharing the thing again. Yeah. So you can yeah, you can scan the QR code, or you can go to slido.com again and then type in this code to join the quiz. Okay. Let's look at this. We'll wait for like a couple more seconds and then we'll start the quiz. All right, guys, let's start the quiz now. All right. So this is your first question. Predict the output. Def add a comma b and then your normal syntax. And then yeah, this is your function and this is the function call add 2 comma 3. So what is going to get printed out? Yeah, so the highlighted part is your function and then the add 2 comma 3 is your function call. So yeah, so what do you expect the output to be? 5, 5.0 or blank? Yeah, so blank means nothing gets printed out. It's like just blank. Yeah, just to make that clear. All right, guys, 8 seconds left. 5 seconds now. All right, so I can see a majority of you have answered 5, but that's actually the wrong answer. The correct answer is blank. Why? Because in the function you have defined it, you're defined to only return a plus b. You haven't asked it to print out a plus b. So so what the interpreter does is it just calculates the value of 2 plus 3 and keeps it as 5. It doesn't print it out because there is no print statement. You're only returning the value. So yeah, that is a small thing you have to look out for. So return doesn't print out the value, but rather it just returns it. You have to have a print statement for it to get for you to see the output. All right. So yeah, that's a small thing. So you guys have to be careful about that. And so moving on to the next question. All right. Sairam has got it correct, and in 7 seconds. That's very good. All right, keep it up, Sairam. Right, so the next question. The if and elif statement should have a condition and the else statement doesn't have a condition. So yeah, is that true or is that false or you can't say? It depends on the situation. So what is it? All right, guys, you can like take your time. It doesn't matter about the speed or anything. I mean, yeah, you can just so at the end of the day, you just have to learn stuff. So yeah, so take your time and just think about the question. You have like 45 seconds to think about it. Right. So 3 seconds left. All right, so 78%, that's yeah. So yeah, indeed the correct answer is true. And yeah, so the statement if and else statement should have a condition while the else statement doesn't have a condition. So yeah, so you can look at it in your notebook as well. So yeah, so here as you can see, it's like this. Your all your else statements have a condition, but only your else statement doesn't have a condition. So else means if it's not if there's no condition in if elif and elif, so it just has to print the else, so there's no other condition for else. So yeah, there's a condition only for if and elif. So yeah, that's how it is. And then yeah, now moving on to your final question. Yeah, and then Sairam has got it right again. Very good, Sairam. It's at 14 seconds. That's good, and he's at the top of the leaderboard right now. All right, let's see. All right, so your next question. It's a pretty simple question. Predict the output for I in range 5. Print I, comma end equal to hash. All right, so All right, so yeah, this is indeed the correct answer. So yeah, this is slightly different from the syntax I've actually told you. This is range 5. I haven't put the starting index, the starting number or the ending number. So yeah, so range 5 means the default starting value is going to be 0. So that's why it starts with 0. And note that your 5 is the final value, so it's going to get excluded. And since I've put end equal to hash, I'm going to get a hash after every iteration. So that's why this is the correct answer. All right, so yeah, that's it. Again, Sairam, congratulations. So I'll be taking questions now. If you actually run question one code in Collab, the output will be 5. Uh, which question are you referring to? I'm not sure. Okay. What will it print in question one in case there was 5 or 5.0? I think it would print 5 only. Okay, I'm actually not sure. Let's check it out. So yeah, let's check it out. All right, so yeah, here we were. Yeah. So yeah, you can see it prints out 5. It doesn't print 5.0. It doesn't print 5.0. It prints out 5. Right. So looking at further questions, what will it print? Yeah. So it prints out 5 if that was output. But so this will depend on where this is executed running on this on the command line will print the answer as well. There is no print. Okay, yeah, that's a good thing. Okay. The logic which we use in C++, same in Python. Yes, I mean logic is universally correct wherever you use it. Only the syntax is the difference. All right. So yeah, what will be the duration of the session? It'll be till 7:30, and then we'll wrap it up. It might extend a little more, like 15 minutes or half an hour. Yes, we will be teaching you how to make all that. There is no switch case in Python. I think there is. There is a switch case in Python, yeah, but in ML you won't use it as much as if and for loops and everything. So here we're actually teaching you basics in Python for ML. We won't be teaching you everything in Python that is not required for ML. So we'll be teaching you basics in Python that is required and yeah, enough for ML. So let's move on to our slides. All right, so now we move on to something called object-oriented programming, and you should know that yeah, Python
Yeah,
is part of
Srijit.
it. Yeah.
Yeah, Srijit. Before going to classes and objects, okay, once could you just briefly describe whatever we have done so far? Because I guess from now on, these are the important topics. So probably you can once brush up whatever we have discussed so far in this session, and then you can go to classes. Okay.
All right, sure. Yeah. All right, so let's just look at what all we learned till now. So yeah, this is why Python because syntax is simple, basic. And then data types, the different data types we learned is your int, float, strings, and then your list tuples will come later, and dictionary sets again will come later, and then Boolean we learned true or false. So yeah, and then now operators also we have learned arithmetic operators, comparison operators, and your logical operators. And then yeah, this is your notebook stuff. And then your quiz, and then your conditional statements. You have learned if statement, if, elif, and else statements, conditional statements. And then moving on to loops, you have learned your for loop and your while loop. And then next, you learned how to define a function in Python. And yeah, I forgot to mention this in your Python user-defined function, it can take how many ever values it wants to input. It can have like n number of inputs and it can have n number of outputs. It can return n number of values, unlike other programming languages where you can return only a single value. In Python, you can return multiple values as well from a function. Yeah. And next, let's move on. This was your quiz. All right, so now here we are at OOP. So OOP stands for Object-Oriented Programming. In OOP, we use objects to contain data in the form of attributes and code in the form of procedures. All right, so this looks a little complex, but don't worry, we'll be learning everything. We'll be seeing it in code, so it'll be much more easier to learn. So don't get overwhelmed so easily. So what are objects? Simply put, objects are objects. I mean, let's not think about it much. We'll look at the code, and then there you'll actually understand what objects are in code. So what are classes? So classes contain blueprints that are used to make objects. Okay. So so basically when I said objects are objects, objects could be anything. They could range from like a pen to a car to a clock to a laptop to a towel. It could be anything. So let's take an example here. So for example, let's look at a car and your car is your object. So yeah, so a car will have its own engine, color, brand, etc. And that is the blueprint of this car, of a particular car. And yeah, so this blueprint is basically your class. So a blueprint is basically, yeah, your class is basically a blueprint to create an object. So yeah, so here these features are the attributes of fields of the car. So these features are basically your engine color brand. So yeah, your engine color brand are the features of a car, and they're all, they are called the attributes or the fields of the car. Yeah, this is your yeah, this is like a jargon. And the different driving modes of the car, of the car are its methods. Yeah, so that's like simply put, it's like an analogous way of thinking about your attributes and your methods in classes. And then yeah, fields and attributes, fields, attributes and methods together make a class. Yeah, and that's what, yeah. And then so totally you have like so classes is like a blueprint to say how your object, to yeah, to like define your object, like to say how it looks like, what does it have, like what does it contain, like how do you create it. And then your methods will be like what can you do with this object, like yeah, so what can you do with this object, like can you like go front, go back, turn around. So that are like your different that like that's like a method for a class. So yeah, so there are different methods for classes. All right, so yeah, this is something called inheritance. So yeah, this is something called a parent class, and this is called another parent class, and this is called a child class. So yeah, this is a picture you can keep in mind, and we'll be looking at the code. So this will make it much more easier to understand. So this, yeah, you can just keep this in your mind, and then we'll yeah, we can understand it much more easily. All right, so let's move on to our notebook. All right. So yeah, classes. Yeah, so classes. A class is a blueprint for an object. It is a way to bundle data even of different data types together. Each variable or piece of data is known as an attribute of the class. So your, for a car, it was an engine or your color or the brand. That was the different attributes of the class. In addition, a class can have functions associated with it called methods. So you remember how you define functions like normally. So now what we're learning is that inside a class, you can define a function just just like only for the class. So you can't use that function for anything else except only for that class. So it's like yeah, it's only for the class. So an object is an instance of a class. This is similar to how the variable num was an integer in the previous example. Yeah, so this was how we are, yeah, that's what it is. So now we'll create, so this is the syntax for creating a class. So class pen and then your normal semicolon, and this is the name of your class. And then now you're defining a couple of variables here called type, color, and price. So class, these are called class variables. And since yeah, and these are called class variables. So for every instance of a class I create, so instance of a class means every object I create from this class. That means like if I create, like see, I created an instance called C1 from pen. So this pen, this C1 is going to have all the attributes as all the attributes type, color, and price as ballpoint, blue, and 100 respectively. Yeah, and then I'm also defining a function. So these functions are also called member functions if they're defined inside a class. So define writing self. So what is this self? This is a way of letting your interpreter know that you're actually referring to your this self is actually referring to the class itself. So yeah, this is, yeah, so this is what it is. And then print. So print write. So this function basically prints write. That's it. All right, so now I've created an instance of a class. This is how you create an instance of a class. So C1 equal to pen and then the brackets. You should not forget the brackets. The brackets are part of the syntax. All right, so now creating an instance of pen. All right, so yeah, this is how you created an instance of pen. And then now if I want to call the member function, I have to write C1 dot printing. Like before, if you just had to call a function, this was how it was. You just had to write odd even. You didn't have to put anything like something dot odd even. But for member functions, as these are like what do you say? Yeah, because these are like only for the only for instances of a class, you have to write C1 dot writing, like the instance dot and then the member function. So here the instance we created is C1. So C1 dot writing, and you would expect it to print out right. So let's check what happens. That's exactly what's getting printed out. That's right. And let's look at this thing. So let's look at self and then something called init. So this init is actually very important. So init is similar to constructors in C++ and Java. So if you don't know what constructors are, don't worry. We just look at it. We look at it in a simple way. So yeah, and explain it to you. And like other methods, a constructor also contains a collection of statements that are executed at the time of object creation. Okay. So I'm creating a class called vehicle, class vehicle, and the semicolon, and vehicle type equal to car. But now I'm writing something extra. Def init self company one color one, and then something here self dot company and self dot color. So what is this? In my previous example, I didn't have anything called def init, but here I have something called def init. So this is something. This is called a constructor. So this tells your interpreter how to construct a particular instance of a class. So here you have self company one color one. So it tells that whatever parameter. So this self parameter is a parameter which you don't need to pass when you're creating the object, but rather you have to send arguments for company one and color one. So what I'm telling it to do is when I pass an argument like this, like vehicle, Ferrari, and red. So I'm telling it to do this. I'm telling it to self.company equal to company one. So self.company equal to the argument I passed, that is Ferrari. So self.company equal to Ferrari. And then the color one I passed was red. So self.color equal to color one, that's self.color equal to red. So yeah, that is it. And yeah, and then I'm again creating a member function called printing, which again is self. So I have, because it is a member function defined inside the class, I have to write this self. And notice that even in the init also I have to write self. Okay, now so what this printing does is this function, it prints out vehicle type, self dot vehicle type, and then company, self dot company, color and self dot color. Yeah, and this class and this vehicle type equal to car is called a class variable, and this will be common to every instance of a class you create. So it'll be common to every instance. So every instance, either like here C1, C2, C3, C4, whatever you create, it's going to have the same vehicle type, that is car, but it could have different companies and different colors. Okay, so now let's create an instance called C1. So C1 equal to vehicle, Ferrari, and red. So the company is Ferrari and the color is red. And similarly C2 equal to vehicle, Mercedes, and gold. So your company is Mercedes and your color is gold. So yeah, so there's something called, yeah, so this displays the details of C1. Print C1 details, C1 dot printing. So I'm actually calling this member function. So C1 dot printing, what would you expect it to print? Vehicle type and then self dot vehicle type, that is common for all the instances of a class. So it's going to be vehicle type car. And then since C1 is a red Ferrari, the company is going to be Ferrari and the color is going to be red. And now if I wanted to access these instance variables or any of these instance or class variables separately, I want to access them separately. Like I don't want to print all of them out. Then I can access them like this. So I have this instance C1. So I'm going to print out C1 dot color. So the color for C1 it was a red Ferrari, so the color is red. And then C2 dot company, it was a gold Mercedes, so the company is Mercedes. So let's just run this and see what happens. So yeah, so C1 print C1 details. This is exactly what's getting printed: vehicle type car and company Ferrari, color red for this piece of code. And then we are printing print accessing class variables using class name, and then C1 dot color, that is this vehicle's color, that's red, and then this vehicle's company, C2's company, that's Mercedes. All right, that's exactly what it is, and then that's getting what, and that is what is getting printed. So now we have something called inheritance. So inheritance is the capability of one class to derive or inherit the properties from another class. So I'll just show you this picture again. Right. So yeah, this picture is basically your inheritance. So yeah, it could be multiple parent classes on top, multiple child classes on top. It could be single parent class. It could be a single child class. So yeah, let's see what that actually is. So yeah, inheritance. So I'm creating a class called company, and in that company, I'm going to have self.ceo equal to Mr. X and self.company equal to ABC. So yeah, so yeah, and then I have this member function called show, which has which is going to print. So this is an F string because there's an F behind it. So F company self dot company name. So it's going to print company ABC and CEO Mr. X. So that is my member function. Then I'm creating one more class called sales employee. But look at the syntax, it's a little different. Like I've put brackets and I put company inside it. But when I was creating a class called company, there were like no brackets here at all, and there was no word I've actually put in. So what is actually happening here is I am creating uh, I'm inheriting everything from company into this. So this tells my interpreter that I'm going to inherit stuff from company into sales employee. So all right. So now let's go on to the init function for sales employee. Def init self comma name. So name is going to be the argument you're going to pass, and then company dot init self. So this is telling that inherit whatever was there in company to sales employee. So yeah. So self dot name equal to name, and yeah, whatever name I'm going to pass as an argument, and self dot salary equal to 20,000, and yeah, so this is yeah 20,000, and yeah, and so because I've inherited company dot in itself, even these variables will also be valid here. So that means if so for a sales employee, if you did sales employee dot CEO, you would get Mr. X, and you would get dot company, you would get ABC. All right, so now in the sales employee, I'm creating one more function called one more member function called def print salary self. Okay, and then what it's going to do is going to print out the salary. So now I have one more, I'm going to create one more class called service employee, which again is derived from the class company. So derived means it's going to inherit everything from company. So that's basically derived. So these are called, this is called your parent class, and this is called your child classes, or this is called your base class, and these are called your derived classes. Those are like different words for the same thing. So yeah, the best one would be, this is your parent class, your company is your parent class, and these are your child classes. Okay, so now class service employee company def init name comma branch name. This is the constructor for the service employee, and this is again telling that I'm going to inherit everything from the company class to the service employee class, and then now self dot branch name equal to branch name. Yeah, so branch name I'm going to pass it as an argument, and that's what's going to get saved as the variable for service employee. And then again I'm creating a member function here, def branch self print. So what this branch function does is it prints the branch and then the branch name. Okay, so now I'm creating an instance of my sales employee, and I'm passing the argument Mr. A. So yeah, in my init function, notice that I have only one parameter, that's name, and I've passed an argument Mr. A. So the sales employee's name is Mr. A. So now if I do emp1.show, let's run this and see what happens. So emp1.show is, yeah, so notice that in sales employee there was no function called show, but rather it was there in your company class. So how is this member function from show coming into sales employee? So this is exactly what inheritance is. So what has actually happened here is your sales employee class has inherited everything from your class company, from this company class. So now you can use this show, this member function called show in sales employee as well. So yeah, so emp1.show that prints out your company name and your CEO name, and that is exactly what's getting printed out. Company Mr. Company ABC and CEO Mr. X. And then now I'm accessing this member function emp1 dot print salary. Yeah, and this is def print salary. This prints out salary and then your salary. So print salary and 20,000. Yeah, and yeah, notice that the salary was actually 20,000. Set your salary equal to 20,000, and that is what is going to get, that is what is getting printed out. So yeah, and now I'm creating another instance of a class, EM employee 2. That, but this time he's a service employee, and in the def init, notice that there are two parameters, name and branch name. So yeah, that is that's the two arguments I've passed here. So his name, so this service employee's name is going to be Mr. B, and his branch name is Delhi. So emp2.show, again, what is happening here? The show is not there in service employee, but rather it is getting inherited from this company. So yeah, it's going to get inherited here, and so you can use this member function called show in service employee as well, and it is going to get, yeah, and what is going to get printed out? Yeah, same thing. Company separate company name, CEO and CEO. So it's going to be company ABC, CEO Mr. X. Yeah, that's exactly what's getting printed out. And then emp2.branch, that is your member function, and yeah, so that's your member function, and this is what is going to get printed out. Print branch and then the branch name. Since this employee two's branch was Delhi, that is what is going to get printed out, branch Delhi. All right, so now That is it. And then now let's move on to our slides. Yeah, so now we are moving on to something called data structures. So data structures are ways where you can save data. So that's like a very simple way to put it. And yeah, this we have finished the first notebook. So yeah, you can move on to the second notebook. That is Python 101 part 2. You can move on to this notebook. Yeah, so I'll be doing the slides first. So yeah, let's do the slides first. Okay, so we'll move on to lists. A list is a collection of entries that is ordered and can be changed. They also allow duplicate entries. Entries of a list need not be of the same data type. All right, so remember how I told you that sequential data types were ordered while non-sequential data types were not ordered? So yeah, that means ordered means you can index them and unordered means you can't index them. So what is indexing? Okay, so this is basically called a list. So a list is yeah, so a list can have it need not be of the same data type, like unlike other like arrays in C++ or C, like where the array should have like same data type. Here it could be of different data types. Here, yeah, it could be a list of lists or a list of tuples. Yeah, we'll come into all that. We'll see all that. So yeah, so this is your yeah, this is your list, and this is a list of length 7, 1, 2, 3, 4, 5, 6, 7, and then this is how you index it. You start from 0 and then you go to 1, 2, 3, and then you go to 6. So that is your length minus 1 because you start from 0. This is how you index it. All right. So Python allows you to allows negative indexing as well. So what is this negative indexing? So your negative indexing starts from the end. It starts from minus 1, minus 2, minus 3, all the way till minus 7. So this is your minus 1, minus 2, minus 3, minus 4 till your minus length. Since your length is 7 here, it's going to be minus 7. Okay, so now let's move on to the next data structure. That's your tuples. So tuples are collections of entries which are ordered in the same way as lists but cannot be changed. All the regular list operators apply to tuples except for those who attempt to change their own values. So what does this mean? So what is the difference between a tuple and a list actually? So the thing with lists is lists are mutable while tuples are immutable. So what does that mean? You can append, you can change, you can do anything to a list. It's like if you had a blackboard, then whatever you write, yeah, so you could, if you had a blackboard and you started writing down stuff on it, like you can erase stuff, you can add stuff, you can change stuff in that. So that's very similar to a list. In a list you can remove items, you can keep items, like you can remove this item, you can remove the you can keep this item, you can remove this item, you can update this item. In a list you can do whatever you want in it, but in a tuple it doesn't allow you to do anything like that. You can't change its values, you can't append to it, you can't change anything in that. So yeah, so let's move on to the next data structure, your dictionaries. Yeah, and a dictionary is a collection of key value pairs which is changeable and does not allow duplicate members. Keys of a dictionary are unique. In dictionaries, keys are immutable and the values are mutable. So yeah, so this is how you create a dictionary in Python. You have this curly braces here, and then yeah. So I told you this. It's something called it's a collection of key value pairs. So anything before the semicolon is your key, and after the semicolon is your value. And then you separate your collection with commas. So this is your first your first key value pair, then your second key value pair, third, fourth, fifth. All right. So yeah. So this is Alex 5, Ben 10. So this is your yeah. These are your key value pairs, and this is how you create a dictionary. Yeah, so here once you declare a particular key, you cannot change the key, but you can change its value. So keys are immutable, but the values are mutable. So I can keep the so I can't change the name Alex, but I can change his number from 5 to whatever I want to, but I cannot change this Alex. All right, so next, moving on. Yeah, okay, so before that, let's move on to our code. So yeah, this is Python 101 part 2. So yeah, let's go here. So yeah, so we'll start with lists. A list is a collection of entries that is ordered and can be changed. They also allow duplicate entries. Entries of a list don't need to be of the same data type. Let's look at some of the examples given below. Oh, yeah, and don't forget to reconnect your this thing. Connect your notebook to your laptop. Or okay. So now, okay, let's look at the first thing. Yeah, so this is your indexing again. It starts from 0 till length minus 1, and your negative indexing from minus 1, from minus length to minus 1. Okay, so now let's look at this. This is how you declare a list. A equal to square brackets and whatever inside it. So these square brackets tell your interpreter that whatever you're declaring is a list. So yeah, square brackets, hello, to, true, and the end. So notice that these are all of different data types. Like this is of string, int, boolean, and again a string. So they don't have to be of the same data type. They can be of different data types. So let's print out A and see what we get. So yeah, you get hello to true and the end. Notice that the order is the same. Yeah. So this is your list, and then you can access individual members of the list too. And remember that the indexing starts from 0. Yes, and your indexing starts from 0, and it goes till this till length minus 1. Okay. So now print a of 0 and a of 2. So what is a of 0 and a of 2? So when you write the list and then you put square brackets and you put a number inside it. So this tells you which which member of the list you want to access. So since zero is so it's so I'm trying to access a member of the list which is indexed 0. So yeah, so this is your list A, and so it starts from 0, 1, 2, 3. So I'm printing out A of 0, that is the member which is indexed 0, and since hello is index 0, I'm going to print out hello. And A of 2, so this is 0, 1, and 2. So this is indexed 2, so I'm going to print out true. So let's run that and see what we get. So we get hello and true as we expected. So as 0 is at the 0th index and 2 is the second index, so 0, 1, 2. So true is going to get printed out. So you can also find out the length of a list using the len function. So there's something called, so this is a function which Python, yeah, which is there in Python. It's called len. So len of a gives you the length of a. What we get. Yes, and we get 4. So yeah, you learned about for loops earlier. Let's use that to make a slightly better list using the append function. So yeah, why do we need this? So suppose you wanted to create a list of like the first 100 numbers. Would you rather write a b equal to and then write this square brackets 1, 2, 3 all the way? Would you type all the numbers all the way till 100? Well, that is one way to do it, but yeah, that's not recommended. So we'll do it this way. So first we'll create an empty list b equal to this. So this is how you create an empty list. And yeah, so print b. Let's see what we get when you print b. So you're going to get b as an empty list. Okay, so for num in range 10. So yeah, so num is going to range from 0, 1, 2, 3, 4, 5, 6 all the way till 9. Yeah, and 10 is going to get excluded because that's the final value. So I'm writing something called b dot append num. So I'm going to append the value. So append means add the add the value num at the end of the list. So that is basically what append means. So yeah, so b is your list name. So b dot append num. So yeah, and then print b. So let's go through it step by step. So for num in range 10. So first num is going to take the value, 0. So b dot append num. So the first value in b is going to be 0, and then it's going to go to the next iteration. That's going to be num equal to 1. So b dot append num. So note that there was already 0 in your in your list. So 0 is already there, and now you're appending 1 to it, so you get 1 as well. Then your num is equal to 2, so you get num equal to 2, and then you append your number 2 as well, so you get, so it goes all the way till 9. So yeah, when you print it out, this is what you're going to get: 0, 0, 1, 0, 1, 2, all the way till 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your final b. Yeah, so your b has been changed officially to 0, 1, 2, 3, all the way till 9. Yeah, so why do we need for loops? This is why you need for loops. Suppose you wanted to print out all the 4-digit numbers in your list. So big numbers equal to an empty list for I in range 1000 to 10,000. Again, I'm putting 10,000 because the last number in range or your last value in your final value in your range is going to be excluded. So yeah, so I'm appending each and every value in 1000 to 9999 to your big numbers list, and I'm printing out big numbers. So let's see what we get. So we're going to get 1000, 1001, 1002, all the way till 1000, 1009, yeah, 9999. Yeah, there you go. Yeah, it's going to be there at the end. I don't want to scroll through it. Okay, now let's take a scenario where you made the list B and you've been asked to extract the second till the seventh element. So will you actually access the members separately and print them separately, like print B of 1, print B of 2, print B of 4, and all so on? Well, yeah, you could do that, but then Python lets us do something called slicing. So slicing makes your life much more easier. So you can, with slicing, you can extract particular values out from a list. Okay, so yeah. So this is basically slicing. So slicing again uses your indexing of your list. So let's look at how to slice. So print B1, and then there's a colon, and then 7. So 1 to 7. So this was your B. Your B was this 1, 2, 3, all the way till 10. Index is, yeah. So 0, 1, 2, 3, all 0, 1, 2, 3. So this basically, yeah, this is your indexing as well as your B, and you're printing everything in B from 1 to 7, indexed from 1 to 7. So what this actually means is that you're printing. So this is going to be start index and end index. So your end index is supposed to be 7, but again, like how in range your final value was excluded, same way in slicing, your final value 7 is going to be excluded. So your indexes, the slicing will happen only from your first index, second index, third index, all the way to sixth index. We get from your first index, second index, all the way till your sixth index, but your seventh index doesn't get printed out. Okay, so suppose you wanted to print out all the elements from your fourth index till the end of your list. So you could do it in the following way. So you write print B4, and then you don't put anything here. So when you don't put anything here, it's basically telling that you have to print till the end. So if I yeah, so this is what it is. Yeah, this is how it is, and then so Python allows negative indices too. And then suppose I wanted to print B minus 1. So as I've told you here, B, yeah, minus 1 is going to be your last element. And in B, what is the last element? Yeah, in B, the last element is 9. So I'm guessing that 9 is going to get printed out. So let's see what happens. Yeah, so 9 gets printed out. And then now again, how I was slicing from 1 to 7, I'm slicing from minus 4 to minus 2. Yeah, so minus 4 to minus 2 is like this, minus 4 to minus 2. But yeah, this is not B. So yeah, let's look at B. So this is going to be minus 1, minus 2, minus 3, minus 4. So minus 4 is 6, and your minus 2 is 8. So again, how in slicing, your last index was excluded. So it's going to be, so what is going to get printed is minus fourth index and minus third index, that is 6 and 7. So 6 and 7 is going to get printed. Okay, let's just run that. Yeah, and then suppose you type your indexes in the wrong fashion, like you put minus 2 to minus 4. So yeah, you're trying to print from minus 2 to minus 4. So yeah, what would you expect? Like, would you expect an error? But yeah, Python doesn't throw an error actually. It tells you that there is nothing between minus 2 and minus 4. So I'm printing out nothing. As there is nothing between minus 2 and minus 4, there's only something between minus 4 and minus 2. So you have to be careful about the order in which you put your indices for slicing. Okay, so now moving on, print minus b minus 5 minus 1. Yeah, so that's again your negative indexing. So now what do we do if you want to increment all the elements of b by 2 and store it in a new list called c? So you would probably think of something like this, creating an empty list, and then for I in range length of b, c dot append 2 plus b of I, and then print c. So what is happening here is this your range is going to be till length of b. So here your length of b was 10. So your range, so this is going to be range 10. That means your I is going to vary from 0 all the way till 9. Okay, so I values are 0 till 9. So I'm going to do c dot append 2 plus b of I. So for I'm accessing every value of b. through this B of I, and then I'm adding 2 to it, and then I'm appending it to C. So then I'm printing C. So yeah, so I would expect this to happen. I'm going from 0 to 9. So I'm going to get B of 0 as 0, and I'm going to add 2 to it. I'm going to get 2. So B of 1 is equal to 1. I'm going to get 1 plus 2, that's 3. So your second value in your list C is going to be 3, and so on and so forth. You're going to get till 11. Yeah, so while this in theory, yeah, this is yeah. So there's something called list comprehension, which is a more efficient way of writing this like in a smaller, in a concise way, and in a more efficient way. And yeah, this is actually much more faster than a normal for loop. So this is how you do it. So C equal to x plus 2 for x in B. So this is called list comprehension, and this is much more faster, and it gives you the same result as the previous one, 2 3 4 all the way to 11. And yeah, so this is x plus 2 for x in B. So for x in B means I'm going to go from all the values in B. Yeah, all the values in B from, yeah, so I'm going to vary from x, so it's going to be like x in B is x equal to 0, then x equal to 2 1, x equal to 2, x equal to 3, all the way till x equal to 9. And then I'm going to add 2 to it. Yeah, I'm going to add 2 to it. So yeah, 0 plus 2, 1 plus 2, 2 plus 2, all the way, and I'm going to get this list again. Okay, so that's how you create your list using list comprehension. Okay, so let's try an example. So here I've added something else. If x greater than 6, so I'm printing out I'm creating a list called D, where yeah, x for x in C only if x is greater than 6. So okay, let's go through it step by step. So for x in C, so x is first going to be equal to 2. So x equal to 2, and it's yeah. So is 2 greater than 6? No, 2 is not greater than 6. So it won't. So the element 2 won't be there in D. So then let's go on to 2 for x and c. So its next one is going to be 3. So is 3 greater than 6? No, it's not. So that also won't be there. So that'll happen till so let's look at the case where x equal to 6. So x equal to 6. So for yeah, for yeah, so if 6 is greater than 6, so 6 is not greater than 6. So 6 is not going to be there in D. Okay, so then the next element is 7. So if 7 greater than 6, only then put it in D. So 7 is greater than 6. Yes, indeed it is greater than 7. Is greater than 6. So D is first element is going to be 7, and then similarly 8 is going to be bigger than 6, and then 11 is also going to be bigger than 6. So your D will be 7, 8, 9, 10, 11. Yeah. So now, yeah, this is how you also create a list comprehension, but with an if statement in it. So yeah, what do we do if we wanted to change only the third element of the list C to number 42? So this was your element C, and then yeah, the third element is 0, 1, 2. So if this is your third element, then the index for it will be 2, because you start your indexing from 0. Okay, so 0, yeah, so 2, 3, 4. So C of 2 equal to 42. So this is how I changed my third element. Notice that I put 2 because the indexing starts from 0. So I'm changing the third element of C to 42. Let's print out C and let's see what we get. So we have successfully changed our third element to 42. Yeah. And then yeah, suppose you wanted to remove 7 from your list, then you just write C dot remove 7 and print C. You can see that you have actually removed 7 from your yeah, 7 from your this thing, 7 from your list. Okay, so let's look at an efficient use of list comprehension. Yeah, list comprehension are way faster than for loops because they use a more optimized internal mechanism. Okay, yeah, but then let's not go into details, as for machine learning this much is enough. Yeah, and you should just know that list comprehensions are faster than for loops. Okay, so now I'm creating a list numbers called numbers from ranging from 1 to 12, and then I'm writing something called divisible by 6. I'm creating another list which tells me if each and every number in this list is divisible by 6. So yeah, so this is how I write it. This is again a list comprehension, but this is much more complex than your normal list comprehension. So divisible by 6 if number is divisible by 2 equal to 0. That means for your divisibility of 6, your number should be divisible by 2 and divisible by 3. So I've added both the conditions. If number is divisible by 2 and if your number is divisible by 3, only then print out divisible by 6, or else print out not divisible by 6 for number in numbers. So for every number in numbers, print out if it's divisible by 6 or not divisible by 6. So yeah, let's print out the list, and this is what we get. So 1 is not divisible by 6, 2, 3, 4, 5, 6, but 6 is divisible by 6, so you get divisible by 6, and similarly you get 12 divisible by 6, so you get, yeah, so 12 is divisible by 6, so you get it as divisible by 6. Okay, so now let's move on to tuples. So this is how you define a tuple. So notice that in a tuple you put this curved brackets, while in lists you put square brackets. So let's print out this tuple. So now, remember how I told you that you wanted to, if you want, you can't change values inside a tuple, but you can change values for a list. So let's actually try changing the value, changing an entry of a tuple. So let's run it. Yeah, so you have actually gone to an error. So you got an error that says you can't change an element inside a tuple, because yeah, that's, you can't change an element inside a tuple, but you can change elements inside a list. Okay, so now let's again go to this thing. This is again your normal tuple operations. You can use list comprehension to create lists from tuples as well. So this is one way to do it. So I'm multiplying every element in tuple A with 2, and then creating this list out, and then I'm slicing it and printing it out. And you can see that for the tuple 3 4 5, index from 2 to 5, 3 4 5 is, so 6 8 10 is exactly double, is exactly double of 3 4 5. Yeah, so, and that is actually what I wanted in my list comprehension. Okay, now, so moving on to the next thing. So if I wanted to create a single element tuple, this is tuple 1 equal to 5. So this is actually not how you declare a single element tuple. If you do tuple 1 equal to 5, then what the interpreter thinks is that this is actually an integer. Well, we'll actually run it and see. So I've declared tuple 1 equal to 5, and then let's run it and we'll see what happens. So type of tuple 1 equal to, yeah, so type of tuple 1, that is actually an integer, but you actually wanted to create a single element tuple. So how do you do that? You write 5 and then you put a comma and then you leave it just like that, and then you print type of tuple 2, you get tuple. Okay, so now, so yeah, suppose you forget to put square brackets, or you forgot to put your curved brackets. What does it default to? It defaults to actually a tuple. So you put tuple 3 equal to 5 comma 2 comma 3. That's actually another way of declaring a tuple. So yeah, it becomes a tuple. So what is a set? A set is, again, it's not used much, but yeah, we'll just go through it. So a set is very analogous to the set you learn in maths. Okay, so this set equal to apple, banana, cherry. So notice that in this, for declaring a set, you use curly braces. So let's print out this set, and then set of, this another way to define it. Let's print this set. So this is exactly what you get out. Okay, so now, like how I told you that sets are very analogous to your sets in math, you can actually find out the intersection, union, and difference of the sets. Okay, so let's do that now. So print the sets 1 comma 2. Okay, let's do this. Okay, and then this prints out your first set and then your second set. So now intersection. So 1 and 2. So that means your element should be there in 1, and your element should be there in 2. So that's your intersection. So yeah, so the elements common in 1 and 2 are 1, 2, 3, 4, 5. If you want, you can verify it. And then union. So this is again, yeah. So this is how you, yeah. This is the syntax for and this is your syntax for union for sets. Okay, so union one. So you can say this as or and this as and. So 1 or 2. That means it should be your element should be there in 1, or your element should be there in 2. So yeah, so the union of your set is going to be 1, 2, 3, 4, 5, all the way till 7. Okay, now if you want to take the difference of your sets, so 1 minus 2, that means every element in a 1,
Split
but
it.
it should not be there in 2. Yeah.
Yeah, I guess you can try to wrap up a little faster because we are on a
Yeah,
time
all right,
crunch.
fine.
All right. Okay.
Yeah, all right. Yeah, perfect, perfect. All right. Okay, so yeah, this is your difference of two sets. And then yeah, now next we'll go on to dictionaries. So dictionaries is kind of interesting. Okay. So this, suppose you had a friend called Manish and you wanted to save his phone number. So phone number equal to, so this is how you create a dictionary. Notice that you used curly braces also for sets, but the difference is that you had your in dictionaries you have a colon here. So yeah, that's how you create a dictionary. So phone number equal to Manish and then 6 for whatever this thing, and this is not a, this is a random number, don't call it. And then yeah, so this is your key and this is your value. So now you print out phone number and you get Manish and 647. So now you meet one more friend called Harish and you want to save his phone number as well. So this is a very simple way to change your actually add an element in a dictionary. So what you do is you write the name of your dictionary, phone number, and then in square brackets Harish, and then equal to this. So this is how you add another element into your dictionary. So you can see that Harish and 96. This is what's getting added. Okay, so now you know that Harish gave you a wrong number actually. Yeah, so Harish gave you a wrong number. So yeah, and this is how I access a single value when I know the keys in a dictionary. So phone number and in brackets Manish, and then I get his phone number outside. So you can see that Manish was the key, and then 647 was the value, and this is what I got as the value. Okay, now so yeah, then you know that Harish actually sent you a wrong number. He gave you his wrong number. So now you do phone number Harish equal to this, so that this like this how you update values in your dictionary. So you run this, and then you get this as your new dictionary. So notice that how it was 963, now it's changed to 969. So yeah, Harish's thing has successfully been updated. So yeah, in a dictionary, you can have a dictionary inside a dictionary. Similarly, you can have a list inside a list and then a tuple inside a tuple. So yeah, let's do this. And then phone number Harish and then equal to this. So yeah, this is how to you're modifying, you're updating your value, yeah, your key value pair in the dictionary. So yeah, Harish is going to be get changed as 9 for thing, and then also this is a dictionary and there's a dictionary inside it as well. Okay, so yeah, this is okay. Rutvik, should I do file handling?
I guess we can skip this.
Okay, and then okay, should I do the quiz?
I guess that's fine. So
Okay,
also
all right.
guys, we have shared all the necessary material or the material, especially the notebooks that we have used for this session on all the WhatsApp groups and also in the announcement group. Okay. So as we are on a time crunch, we'll not be going through this, but definitely you can again run the cells on your notebook and you can look into this part. And if you have any doubts, definitely you can reach out to us. We'll be available on all the WhatsApp groups. And also, if you have any doubts, you can even post them on the Slido Q&A page. Fine. That's all about it. And congratulations, you have learned the basics of Python. And also, few of you were asking doubts regarding do we need to know Python up to the extent of data structures and algorithms? But we are covering Python, especially keeping machine learning as the use case in mind. So we have covered all the fundamentals which will be required for machine learning. As a machine learning practitioner, what all skills you need specifically, only those have been covered. Okay. So we'll take a 5 minutes break and then Sumedh will be starting. We'll be looking into NumPys and Pandas, which are the very popular Python libraries which are used in the machine learning world. All right. Yeah.
All right. So the quiz right now, should I do it?
I guess we can hold it.
Okay, all right.
We'll be starting in another 2 to 3 minutes. Probably, I guess all of you can react with a thumbs up, or if you have followed so far and if you are able to understand most of it that we have discussed so far in this class. Also, as I mentioned earlier, we are sharing all the material on the WhatsApp groups and also on the announcement group. So if you have any further doubts, you can reach out to us. We'll wait for another 2 to 3 minutes. Yeah, Karthik. Okay, cool. Srijit, if possible, can you share your screen and we'll go through some of
Yeah,
the
yeah,
Q&A
sure. I'll
questions. Okay, yeah, cool.
yeah, I'll go through the Q&A. It's all right. All right. So yeah, yeah, you guys, you can start posting your yeah, sending questions on the Q&A thing. Where will we get the homework? There's no homework, but then yeah, you can you'll get the notebooks and the necessary data on your WhatsApp groups, or I think the links will be put on your on the YouTube chats as well. So yeah, you can look out for that. And then when are we using the name argument passed for same service employee? Okay, so when are we using the name argument passed for service employee? Okay, let me just go to that. I don't think I printed that out, but yeah, you can print that out. Are classes similar to structures in C? Yes, they are similar to structures in C. Explain scope of a function and where we can access like that. This you don't have to go in this much depth for your ML and all. So yeah, that is yeah. Your attendance link will be shared. What questions are asked in AI ML interviews? So this is very basic. So you will have to these Python basics you will have to know. But the questions you get in AI ML AML interviews will be what is going to come in your further sessions. Okay, is a knowledge to be able to solve? No, it's not required to that extent, but a little bit. Yeah, this much basics is enough. Do we need to do? No, you don't need to do it as well. Okay, so we can convert words to int. It gives sum of ASCII values as an answer. Oh, okay, I actually didn't know that. Thank you very much. Okay, okay. Okay, these are like the answers. Guys, any questions? You can post it on the Q&A link that we shared. I'll just show it again.
I guess it is fine. We'll again come back to it at the end. Sumit can start right now, I guess.
All right, fine.
Okay. Okay. Cool.
Yeah,
I,
perfect.
uh,
Yes.
I just wanted to make sure that the collab notebooks for NumPy and Pandas have been sent in the relevant groups and in the discussion group. The collab files for NumPy and Panda have they been sent? Uh,
Can people
okay,
react
guys,
if you are able to open the collab notebooks that we have shaped right through?
has it been sent in the first place? I'm not sure because
Yeah.
yeah, please guys react if you guys can open it and if you're able to copy it, make your own copy because the version I share will not have edit access, right? Okay. Is anyone can anyone like thumbs up if you are facing any problems? Can anyone thumbs up if you're not facing any problems? Like just general thing is going fine. Can anyone sort of acknowledge? Yeah, fine works. Okay. Nice. So okay, cool. And I will start with my presentation. So I hope you guys all had a nice introduction to as to exactly as to how Python works. So now we'll be sort of moving to the one of the most important libraries that you have in most basic fundamental libraries that you have for any sort of ML practitioner. Not just for ML, but a lot of applications, and that is NumPy. So like introduction to NumPy, right? So I will be starting in around a minute, around a few seconds. So if you guys have any sort of questions, you can put it in the Slido box. If you feel I'm going too fast, feel I'm going too slow, again let us know so we can act upon it and help you guys. Okay, is that fine? Is everyone okay? Can everyone sort of like put like a thumbs up or something? Yeah, fine. Yeah, so let us begin. Okay. So what is NumPy? So where do we get the motivation for a library like NumPy for? Right? If you if you look at data for any sort of application, you'll see the data has a lot.
Just hold on for a minute, guys. I guess our instructor has lost his connection. He'll be back. Okay. Yeah.
Sure.
Sumit.
Am I audible?
Yes, you're audible. Okay, fine. Go ahead.
Is my screen sharing visible? Screen sharing visible.
Yeah, your screen is visible.
Okay, what was the last thing that was heard?
I guess you can restart. You were talking about NumPy.
Right. Fine. I'll start again. So okay, cool. So the first thing you guys need to know the question is why do we need something like NumPy? And because as I've talked about earlier, is that data has a lot of parameters and attributes which we need to manipulate in many various mathematical ways in order to feed them into our machine learning models, right? So and the kind of operations that is why you have NumPy objects as a sort of replacement to lists and tuples and arrays and other forms of iterable things that you can find in normal Python, right? So what is the advantage in NumPy? What operations do we find in NumPy? Is that many times the operations you sort of need to perform in a machine learning model is what you would call linear operations. Things like adding, things like performing a function across all of them, things like scaling, right? These essentially these linear like addition is linear operation, right? So these linear operations is something you can control and perform via NumPy operations very easily. NumPy performs and gives you a nice way of sort of handling this sort of iterable arrays, right? Am I audible? Is everything clear? Yes, sure. Am I audible now?
Yeah, you're audible.
Right. Yes, sure. One sec.
Can you share your screen? We are not able to see this.
Yeah, sure.
Okay.
Give me a second. Yeah, is it visible? Hello, is it visible? Can I get some?
Yeah, cool. This is good.
Sure. Um, so what was the last thing that was heard? I'm just trying to clarify because uh, hello?
Yeah, you were explaining about how NumPy is much faster.
Yeah, so basically it helps you perform linear operations much ease and much convenience. So with that being said, let us actually go into the world of NumPy. So the question now is, this is sort of an index as to what we'll be covering in this sort of presentation, and we'll be implementing them via Colab notebook in due course of time, right? So let us start. First thing, what is NumPy? NumPy, as I mentioned, is an open source library that concerns array manipulation. Why is array manipulation something we care about? Because vectors and matrices and tensors is something that's out of the inherent part of any ML model, and therefore it is important to find a way in order to manipulate them in useful ways. And like I said earlier, it has various mathematical operations it can perform, like arithmetic, trigonometry, Fourier analysis, matrices. The list goes on, and we will discover them as time progresses in this sort of presentation, right? Uh, okay. So the question is, what makes NumPy so useful? Like, why do we want NumPy over our regular Python, right? Because NumPy is, as you can see, is very important, famous. It is much faster than this. NumPy, as you can see, NumPy is much faster than this, and you don't have to type checking. Because some type checking is something that takes up time when you're doing any sort of presentation. See, I'm sorry, when you sort of any sort of ML model, and therefore type checking if you don't implement it, it'll save a lot of time. And NumPy is a contiguous memory, and we'll explain what this in due course of time, like in the next slide. So what does contiguous memory means? It means that you're essentially storing the values in a continuous cells in an array. Okay, like you can see, there's a next to each other, and where normally you don't store them next to each other. Why does it make NumPy faster? Because in any program, when you're collecting data from your machine, you will need to devote some time to memory access, and the process of memory access becomes a lot simpler in NumPy as compared to list, right? NumPy you just go from 1, 2, 3, 4, 5. List go here, come out, go back in there, go out, go back in there, go out, go back in there, go out, and so forth. Therefore, NumPy becomes a much faster way in order to store access memory, right? Uh, Next, I think Shisha talked about this in the context of list and tuple, but also let me just reiterate what he was trying to say. So, as with any iterable array, you will have things like indexing and slicing. What does indexing mean? It means that let's say you think of the NumPy object as like a box, okay, and let's say there are it has a lot of chocolates, and let's say you specifically someone wants you to come and collect a 5 star. You can't just put your hand in the box, eyes blind, and be like, this is my 5 star, right? So you need a systematic way of knowing which element of the box is going to be a 5 star, which is why you have things like an index. The index tells you, gives you puts every object in there and tells you this is your index number, hence the term indexing. So the process of indexing is basically using the indexes to find your elements within the NumPy object. What is slicing? Slice in many times in operation you need to find, let's say you have the same box. Let's say you want to make a smaller box based on what's present in the contents of the box. What you'll do, you would perform a slicing operation. What is a slicing operation? A slicing operation will basically take a sequence and make a subsequence of it and use that for whatever purpose you want it to be. That is the thing of slicing. So slicing has this index system where we use start and end, where it is inclusive of the start and exclusive of the end. Right? I think this is how something she covered in this presentation. Okay. So now arithmetic operations, stuff like numpy.power, which basically which takes every element and performs a raise it to a certain power at once. This is very again useful for large scale data manipulation. Similarly, trigonometric does it for makes trigonometry functions, add, subtract, multiply. They do the same thing. They basically go element wise, and they basically perform these operations. These operations are very useful, and we will implement them in a few minutes. Right now, these are two very important concepts in basically any detailed numpy objects. One is the concept of shape, right? Shape gives you an idea as to exactly how many dimensions there are, and within each dimension what is the exact number of rows and columns within each dimension. Okay, why does it matter? Because when you're performing any sort of operations within NumPy, you basically need like you need to make sure this, as you know, matrix multiplication is not always possible, right? You need stuff to be of a certain size and certain dimensionality in order to be able to perform matrix multiplication, right? So therefore there needs to be, you need to be sure that the shapes are of the appropriate size before you multiply them and perform any other matrix method, which is why that's why the concept of shape comes in, because it allows us to check what the shape of our NumPy object is in, right? So how we essentially store it as is that if you have, let's say, a two-dimensional NumPy object like the one we have here, it basically goes like columns, rows and columns. If you have a three-dimensional object, there will be a third variable at the end of the rows and columns. And but we mostly won't concern with it in a code, but it is something that's only an intuitive extension of what we're doing right now, and it's not very hard to understand, right? What is stacking? Stacking is the process by which you take existing arrays and make it bigger newer arrays. Why does it matter? Is because we often need to use arrays to and make other arrays from existing arrays. And this is basically there are many different forms of stacking. One of the forms that is shown here is vertical stacking, which basically if we assume that if you have the number like 2, 3, 3, 4, 1, 8, 0, 4, it basically stacks along the vertical axis sort of. So it becomes 2, 3, 3, 4, 1, 8, 0, 4, and then that's what I end up getting here, right? Okay, fine. So now there are many. So like I said, like I mentioned earlier, the concept of shape is very important when you are doing when you're doing any sort of matrix method. I mean, any sort of matrix operation. So it's important to have ways of manipulating that shape apart from just checking on it. So the first thing is the concept of array.ravel, which basically flattens a multi-dimensional array. What does it look like in practice? We'll look at it in a code in a few seconds. I just need to make sure you guys know something called array.ravel exists. Now these are two very similar but slightly different operations called reshape and resize. What does reshape do? Reshape basically takes the array and spits out a reshaped array without actually affecting the original array. So what you'll have is you have your original array, but it also return a value which is your reshaped array. Dot resize basically changes the original array itself in its place. That is the main difference. There is no other semantic difference between reshape and resize because they both sort of restructure the array based on your input dimensions. How do we use this? We will again see this in a while. Okay. So there are also some useful functions that we sort of need to do when you want to initialize NumPy objects. One is the concept of NumPy.zeros. Basically tells you, okay, you give me the size, I will fill every element as 0. Then it's a very useful way of basically initializing a variable, and in this variable being the NumPy object in this case. Okay, let's say you don't want to fill it as any 0, you want to fill it as any other number. You can go for it as NumPy.full. And basically NumPy.full, and if you put the second argument as your 0, essentially same thing you're doing as NumPy.zeros. And a third very useful thing is NumPy.identity, which basically doses out the square matrix, which has its diagonal element is 1 and every element is 0. right? This is the concept that you sort of see carry over from linear algebra, and it's a very it is a very useful NumPy object to generate, NumPy method, right? So, and the last concept is question of file reading. As you can see, this is sort of a code you can do to read files. And we sort of understand the problem is that reading files using NumPy is not perhaps the best way to read it. This is why you have the concept of pandas. So
Sumit,
if you had, yeah, sure,
yes, Sumit, can you be a little slow? Few of the people
sure,
are finding it difficult to understand.
sure,
Okay.
sure, sure. Which
Yeah.
section would you like me to repeat? Is there any specific
Uh,
section
uh,
that you want?
there's no particular session, but right from now on, try to be a little slow. That's all.
Yeah, fine, fine, fine. Okay. So the file reading is something that you don't use as much as NumPy. It's a lot more convenient to do with pandas, and we'll sort of understand why it is more convenient with pandas in due course of time. Okay. So with that being said, does anyone have any doubts to the presentation so far? You can ask me. I'll sort of try to clarify, and after this we will move to the code. Okay. Does anyone have any questions? Ruthik, is there any questions people are asking in the chat slash in this?
I guess there are no specific questions. You can proceed.
Fine, fine. So at this juncture, what I would ask, like you guys to sort of do, is uh, is sort of open the collab notebook if you can, make a copy of it. How do you make a copy of it? Is basically go here, you can make a. Is my screen visible? Firstly, Ritvik?
Yeah, screen is visible.
Okay, fine. So you can basically make you can save a copy in Drive, and you can open Collab Notebook, and you basically can open it one more time with your own copy, so you can edit your own copy. The reason I'm asking you guys to edit is because we will probably be doing a code. We'll be doing a code along, so it will be a nice experience for you guys to get your own hands dirty and sort of code along with me. Is this something that everyone has been able to do? If anyone facing doubts on how to copy a notebook, if so, please ask.
Can you guys react with a thumbs up if you are able to do it? That'll make it easier for us to understand if you're following and on track with this.
Okay, fine. Seeing no issues, I will sort of proceed, assuming that we guys all understand, we're all on the same page here. Okay. So we will be using a data set where it is called serials.csv. So so first thing, what is a data set? So when you're feeding anything into any ML model, you will be needing uh, a file which sort of has all your, like I said, parameters and whatever values it has for every sort of iteration that you're using, every sort of input you're giving, you need to give a sort of parameters. For example, if you are using the context of, let's say, how much of Virat Kohli, what is Virat Kohli as a player, you can have like batting average, you can have like high scores, number of centuries, and next you can sort of have like a list of cricketers with all their batting averages, high scores, and centuries, right? That is the concept of a data set. So the data set that we are using is something called serials.csv. As you can see, we will sort of explore what it does and sort of explore it as over the course of NumPy and the two collab files we have presented so far. And hopefully this will be an experience that we can all learn together, right? So the first thing, as you can notice at the start, first off, we are using pandas to read the file. What is pan? Sure, go ahead. Could you zoom in? Okay, fine. Which fine, no problem. Is this fine? Okay, fine. So the question is, what do you? So question is, what do you? As you can see, first and foremost in the first cell, we are using pandas to read the CSV file. Because again, like I said, pandas is very useful. How does the CSV file imported? Basically, we have the CSV file on a GitHub gist server, and we're basically directly calling it from there. Collab Notebooks offers you this feature where you can basically save stuff in just in GitHub, and you can call the file from there. So essentially, what we're doing is we're basically calling the file from there. We're basically reading it with the pandas library, and we're outputting what you call a data frame. What is all this? We'll be looking at in the next file. But all you should think of it is this is a black box, which basically takes which basically takes your data frame and basically converts into an array, an interval array that we can use and that we will use. Okay, so with that being said, let us run the first cell. Give a time.
So maybe if possible, can you switch to dark mode?
Sure, sure. Is there something everyone wants?
Yeah, if you are finding it uncomfortable.
Okay, fine. 1 second. 1 second. Wait, how does one make it dark mode?
Check the view option.
Hmm. Hmm.
Okay, just it.
1 second. Huh? Yeah, done. I've done it. Is this fine? Is it better for everyone? Can everyone see the change?
Yeah, they should be better.
Okay, fine, nice. Cool. So we have, so as you can see that we have imported the pandas library and basically converted it into an iterable array that we can use, right? Nice. So now this is where our numpy or hero numpy comes into play. And before that, so what do we want to achieve by the cell? We want to take our iterable array, which is your rows, and you want to convert it to a numpy object. So how do we convert a numpy object? We have something called np.array, which basically converts your rows into a numpy array, right? So how will this work? I'm so sorry. You write np.array and you can write rows. That's the variable name, as you can check. Yeah, sure. Huh? What? Zoom. 1 second. Zoom in. Is this fine? Fine. So as you can see, you're basically performing np.array on, because this is the operation converts it to a numpy object. So you have converted a numpy object. Next, what you want to do is basically print the numpy object, which is where you do rows dot array, and then you do rows array. Sorry, endim. So what is endim? Endim is basically it sort of is an attribute. And basically, you can it's an attribute of the numpy object, which basically returns the dimensions of your numpy object, as you can see. And you want to return shape, you do similarly has a dimension called shape, you return it. So if you run the cell, 1 second. Oh, sorry, I made a type it wrongly. Let's go again. Yeah, see. So as you can see, it has printed a numpy object, which is this. As you can see, it has 100% brown. Next row, next column is n, c, so on and so forth. It has 2 dimensions and it has shape 77 16. What it essentially means is that it has 77 rows and it has 16 columns. That is what you're supposed to interpret by the term shape. Okay. Now the question is, how do you slice numpy objects? Because as you can see, numpy objects will have more than 1 dimension. So how do you slice them? So essentially, anything sort of looks like a times range 1 range 2 for a 2 dimensional object. What does this mean? It means that range 1 basically specifies the range of rows from which you're slicing, and range 2 specifies the range of columns from which you're slicing, right? And range is equal to start equal n plus 1, because it is, why am I saying n plus 1? Because it is not inclusive of the end, right? So just ignore this line is wrong. But and next thing is sort of says that the as type function. What is as type? As type helps typeset your cast your array to a specific data type. Why is this important? It's important because in many times we sort of want our data type or of our numpy array to be of a specific data type, because our ML models often many times is integers, because that's what our ML model wants. So that's what I have a data type called np.in64, which is a 64-bit integer data type, which means they can store number until 2 power 64. Okay. So now, so first thing is we want calories, and as you can see from this table, calories is the 0, 1, 2, 3. It is the third column. So we want to print. We want to get every We want to get every version, every row within uh, within the array. So we just write. We don't specify what the range is. So this is our range. Basically, it's I'm specifying nothing, which means we'll have everything. That's how it works. And since we only want the third column, which is what calories pertains to, we'll only put three. We won't put a range. Okay, so that's what you want. Similarly, the protein is the fourth column. If you guys want to see how it looks like, you can look at this. You can look at this thing. You can see what your columns are. So 1, 0, 1, 2, 3, 4. 4 protein is your fourth column, right? So which is why I will when you essentially what you can do is take this code, copy it, put it here, and basically write 4, right? Similarly, now you want to typecast it. So what do? You write calories as type np.int64, and similarly you will write protein dot as type np.int64. So basically you have casted into 64-bit integer. And as you can see the calories array and the protein array. Why is this? How it can check is there's a calories array. We can basically go back up here. We can see that it is 70, 120, 70, 50. Similarly, it's here also. It's 70, 120, 70, 50. So we can see it has printed the right array output. If you want, you can go. We can go here and see again that the calories is 70, 120, 70, 50, and so you can see that it has correctly printed out the specific row from specific column from that section. Okay, so okay, fine. Now let us. Yeah, sure. Is there any question? Okay, fine. Okay, fine, fine. Which is there any specific part people would like me to re-explain? I am fine. I can do it. Okay, fine, fine. Is there any specific section they want me to repeat? I can repeat. Just can you ask them in the chat now so I can know is there any specific section they want me to repeat? Yeah. Sure, sure, sure. Okay, one second. I'll cover the doubts after I finish the NumPy collab file, and then I'll just reverse and enter the doubts and tell you. If you want, if it's possible, try collating those doubts so I can respond to them.
Yeah, I
Okay,
guess that is better.
so okay, fine. I'll continue. So okay, so let us know. So since we have typecast our calories and protein, since we have typecast our calories and protein, the question is now is how do we find what the data type of the calories array is, right? So now we have this basically tells you dot d type is also like an attribute of like a dot d type is like an attribute of any NumPy object, which is in this case the calories. Dot item size is the size of each item, and basically this is more of a response in terms of bytes, right? Because we take int 8, it will give 1 byte per item because that's the data type of every item. And next is size. So it represents the net size of the array. We'll see what this means. Int 64, because we again remember we typecast it here to int 64, which is why we can see that it is given the correct data, which is a nice satisfactory thing. Int size is 8 because it is int 8, which is 1 bit, and 1 bit is 8 bytes. See, 1 byte is 8 bits. Okay, so it will give the number of bits is 8 bits, which is 1 byte. As you can see, 1 byte, right? And the net array size is 77, which basically means that again, like you said earlier, we saw that there are 77 rows in this data set. So which means that the number of rows in this array is 77. Okay. Now the question is, what if we want to access a specific element? Now the way I would actually to individually think about this is that imagine if we had a coordinate plane. On that coordinate plane, how do you specify any point on the coordinate plane? You use its coordinates, right? So let's say we want to access, it'll be like 3, 4, 4, 5. Those are the coordinates. Similarly, if you think, you can also think of your data set as like a coordinate plane. And if you want to access specific element, you basically have to give its exact index number, which is specified by two values. One is indicating row, and the other is indicating column. Right? Let's say it's 5, 1 is giving G. How do we check this? We can go here, right? We can see, okay, what is 5? 0, 1, 2, 3, 4, 5. and first thing is G. Apple cinnamon Cheerios, the first thing is G, and what it has given me here is also G. Now, what if I made it something like 2, and for the experimentation, let's make it 2, 0. Okay, so just checking out beforehand what is 0, 2, it should 2, 0 should give 100% natural brand, and hopefully it will give me 100% natural brand. We give sorry, so 0, 1, 2. I made a mistake. This is 0, this is 1, this is 2. So because again I made a mistake, easy mistake to make. Basically, I forgot the row start from 0. So similarly, if you want to get 100% natural brand, you type 1, 0, and you get 100% natural brand. Right. So you can see as to how this coordinate system of works. Basically, you can give the row index number, the column index number, and you can basically find out what you need to access via this process. Okay, fine. Now we can see there are 3 functions here, which is np.square, np.sign, and np.power. Okay, how do we use this? What does this mean? We basically means if we want to, let's say, go element by element and square it. If you want to be like, okay, let's say you have 1, 2, 3. If you want to square it, you want to make it 1, 4, 9. That's what your np.square does, right? Your np.square. If you want to go write rows, okay, let's do it for calories. That's what that's for. Similarly, if you want to make sign, as you can see, this is all given here, right? np.sign protein. And if you want to give it here, np.power. Let's say squares, right? Let us raise it to the power 2 to sort of just compare as a sanity check. We want to just compare between what are this power operation will give and what my square operation will give. Okay, so you can see the calorie square will essentially give me this 44900 4900 You can, as you can see, the calories that we did with the np.square method and the np.power method end up giving me the same thing. And you can see the sign protein also gives me, you can see it performs a sign operation in each value of the data set of calories, that is, and protein, that is. And as you can see that every number is between -1 and +1, so we can have a sanity check. Okay, maybe this is actually a sign function, right? So let's say for experimentation, let's make it 1. Oh, sorry, let's make this 1. Okay, now what will happen? You get 70, 120, 70, 50, 50, which basically is like I did nothing at all. Which basically like raised to the power 1. You can see that you can also make it power 3 if you want to check it out. And see, the numbers become bigger. So you can see this is how np.square, np.sign, and np.power works. Right? So this is a sort of a nice introduction you will have to these sort of functions. Now the next set of functions is different from np.square, power, and sign, is that they require two arguments. So those you could see were unary operators, here are binary operators. As you can see that addition np.add calories to protein is is a is sort of add numpy add calories and protein. np.subtract calories protein will basically subtract protein from calories. As you know, subtraction is not commutative, so it's important to know that the first basically subtracting the second argument from the first argument. That's like a normal subtraction. And a numpy dot multiply basically goes element by element and multiplies each other. So numpy or multiply calories comma calories should ideally give me the same result, np dot square. Okay, let us see if it does give me those results. As you can see, multiplication basically again gives me the same response as if you look at here. You essentially see that it is giving me this requires this string of numbers. You'll see it's producing exactly the exact same string of numbers. Why? Because you're multiplying the thing with itself, right? If, for example, if you wanted to, let's say, addition subtraction, you can see it's basically adding your two quantities, right? Subtraction is actually subtracting each element twice. Let's say you want to, so you can see that basically what is doing is a good way of adding two vectors, adding two matrices, or basically any sort of numpy object that you have. Basically, add that element by element, right? And the last section on numpy will basically be on second last section on numpy will basically be a section on rabble operations. So what is it? How does rabble work? You can look at this matrix and basically see when you perform a rabble operation, it basically squishes it down to a linear operation of it's a linear array of one row. Like it basically becomes a one-dimensional thing, right? So this is how it works. So as you can see, the purpose of rabble is basically converted to a 1D vector. As you can see, this is exactly what has happened in this example case. So let us now, similarly, we can understand what is happening after running the cell. What happened here? Sorry, this is yeah, never mind. Let us run it for, let us, so as it, we can, let us see for let us try for, let's say, protein, and let us try again, let us again do this for protein. Let us again do this for protein, right? So as you can see, basically now, basically, if you looked at what a protein operation was, basically it basically converts. Let us look at here for a sanity check. Basically it takes protein, which is basically in form of like, which is in the form of 4, 3, and basically it converts into a one-dimensional vector. As you can see, this is exactly what it has done. It has converted into a four-dimensional vector, right? Oh, one sec. I think there's a slight mistake here. Let us run. Let's say perhaps 110 calories. And let us actually initialize. Let us actually initialize a array here for reference. Right. So we can basically define what we wanted to do here, and let us basically, and let us just type. Let us just see what those things look like on this. Right. So you can see this is what A looks like. This is what B looks like. And basically, that's not anything a mystery, because they are the same thing. The why the code initially didn't work is because I didn't because I used the same thing, and I used the same data type over and over, even after it is manipulated with. This is why those resizing operation would not work, right? So let us now run it, and this not look, right? So you can see after some confusion, we can see that basically when you unravel A, it becomes 1, 2, 3, 4, 5, 6. If you reshape what essentially was a 2 into 3, what essentially was a 2 into 3 matrix, becomes a 3 into 2 matrix. But you can see that, one second, yeah, what essentially so one second, let us run this cell again. Let us run this cell. Yeah. So again, yeah, this finally. So what essentially happened was, this is after you reshape this structure essentially ended up becoming this structure, but the original array's format is still preserved. And once you basically run resize, it basically changes the thing in its place. Here we basically here when you asked it to print the original B, it basically gave a different structure. But here when you ask it to give a change structure with resize structure, basically it gives you can see that it changes the thing in its place. So that's the difference between reshape and resize, right? And this is the last cell we will run, which basically shows you that the np.zeros operation basically creates a 2, 3 numpy object, which every element is 0. 99, which it takes a same 2, 3 object, makes it all 99. And the 3 into 3 identity matrix basically converts the order 3 identity matrix. So that is all we have for numpy now. So, so we'll now move to pandas. Before we start that, do we have any questions? Hello, is there any questions? Rodway, can you?
Yeah, if possible, can you share your once? Can you open the Q&A page and take up some questions?
Sure. Let us see.
Probably consider taking the recent ones.
1 second. So once again, no questions have been asked in the last 20 minutes. Is what I understand.
Yeah, can you scroll up once? You'll be able to sort it based on popularity or latest. Yeah, click on recent.
Okay.
Should have popped up.
Okay. Yeah. I don't think there has been any. There hasn't been any questions last. Is there any questions that have been asked on YouTube?
Okay, fine. I guess the YouTube questions are being handled by the other coordinators.
Right. Fine.
I guess you can
So
proceed with pandas. Yeah.
yeah, one second. The Ravel part, okay, sure. So let us go back there. I think there's some confusion when I explain that part. Yes, no problem. So okay, so what does Ravel do? Okay, Ravel basically takes this NumPy object, which is of this format, and basically outputs something that is of this format. How is this output format semantically different from the first format? You can see that this what essentially makes into of something that is like a n into one a matrix. An n into one matrix is basically like a one is basically like a vector. Right? Basically this takes a 3 into 2 matrix and makes it into a 6 into 1 matrix. So when you want to make something, when you want to make something something times one matrix, when you basically want to make it like want to reduce the dimension effectively, basically use the ravel operation, right? So similarly, so that's what ravel does. Reshape basically takes the thing which is again a 3 into 2 matrix, 3 into 2, and output something at 2 into 3. But the semantic difference there, it does not change the original array. It makes it continues to remain make it at a 3 into 2. And and what the resize option does is it takes a 2 into 3 matrix and makes it 3, so and basically changes the thing in its place. So here when you outputted b, you didn't end up getting this format. You still ended up getting the original array, but here when you output a resize, you basically end up getting a changed array. Is that fine? Is there any other questions? Okay, cool. I'm start with pandas. Fine. Okay. Okay, let's start. So, can I start? Is there any sort of question that people have? Yeah, Ritu, can I start? Hello, am I audible?
Yeah, you're audible.
Let's start off with pandas. Okay, fine. So, the first obvious thing to do is any uh, libraries to start off by importing it. So always the first imports are often slower because that's how it works. It's still connected to things like GPU. So so basically ends up. Yeah, sorry for that. So it so basically you can start off by importing pandas as PD and putting up as NP and import copy. And you can see this is basically the operation you do to read CSV, which is basically dot read CSV, PD dot read CSV, which is basically what as you saw, you can basically read this link from that. I'm sorry. You basically read this link from earlier as you saw, and basically we will read it again. So this is how you read CSV file using pandas. It's a very simple operation. You just read CSV and then input the link of whatever file you want to import. If it's a local, and with the proper like a route. Here, since we're directly using GitHub gist, so it becomes an easier process. But normally, this is what you do. Okay. So now the first thing you can, I think, here what the central part of the pandas library is something called data frame object, DF, right? So what do we try to achieve by the data frame object? We can, first thing, it has an attribute called columns. What does it do? It's in the same serial.csv. We can see that, okay, using the name, manufacturing, type, calories, protein, fat, sodium. These are all the names of the columns that we saw in this slide. We saw these are the names of the slide, like manufacturing, type, protein, as you can see, right? So that's what the columns attribute returns. We say returns all the columns that are in that. Now let us try to access specific rows of a particular column. So as you can see that this 1:4 returns the second, third, and so returns the second, third, and fourth row of your data set. So the second, third, and fourth. Second, third, and fourth. Right? So this is what is being outputted here. Right. So okay. So let us so let us uh let us sort of play around with it. Let us make it reduce it to this. Right, what we can see essentially outputs is now one lesser row, because again it takes what is giving us an input is basically the input range of all the rows. So we're actually giving 1:3, which is 0 1 0, which is basically 1 and 2. We will not input 3 because it is not inclusive of 3. So 100% natural brand and all brand, right? So this is what your df.dataframe.name does with your index list. Okay, now this is a very important process, which is basically you take the columns and you rename them. So how do you do this? So basically, you write your attribute, which is columns, and you put a dictionary, which is saying, okay, these are all my old column names as the keys, and these are all my new column names as their thing. Why is in place equal to them? We will find it in just a second. So let us run this cell. I think this cell ran. So what is in place equal to true therefore? Well, basically means that, okay, instead of creating a new data frame and putting it there, you can basically take out your existing data frame and replace the one on top of this. So basically it's a way of saving memory in large scale applications. So now that we have sort of sorted our data frame, let us actually look at it. The more it takes some time to load. Okay, fine. So as you can see, it's a very nice representation. You can see name 100% brand, manufacturer N, type C, calorie 70, protein 4, etc. You can see this is we can visualize data set like this, right? We can see this is what happening. Now let us look at what is happening here. Okay, so first thing is that we let us look at this operation that is called df.log. So what does this do? This df.log basically takes on a logical operation, value, and as the thing satisfies the logical thing, it basically performs an operation. Here it checks if data type is equal to x, and this is the type value is equal to x, and if it's that type, it basically it changes the type value to this new thing. Basically, it's saying that, okay, if your type value in the data frame is x, basically changes the type value to y, right? Why is this important? Because it helps with readability in this case. When you have type equal to C, it doesn't really tell me a lot. Or let's say when type C equal to cold, then okay, it is telling me something that, okay, then the type value is cold. Similarly, if you want to make it, let's say want to change it, let's say do the same thing for, let's say H is equal to hot, you can do it here, right? Similarly, you can make it manufacturer is, e- is equal to, right? So why is this thing? Because we want to see we have a code. Okay, A is equal to American Home Products, G is equal to General Mills, K is equal to Kellogg's, and so on and so forth. So we're just making sure that everything's of a more readable format. Yeah. Similarly, let's just take this thing, we put it here. Let us type these two lines up from scratch. Okay. So what we're basically seeing here is sort of a manufacturer that will cause an error. Manufacturer, right? So this is basically a way of changing your all of your old manufacturer names NAKB, basically making it a more legible Nabisco Kellogg's. For this point, you might be asking me, what is the lock operation do? So lock is a way of accessing a row provided a certain logical input. Basically, it's a way of checking inputting only your selected rows, that so that when it satisfies like a proper criteria. Like here we're checking if the manufacturing equal to n, that's your logical expression, and with that that's what the lock thing does. Lock is often associated with the logical expression within it. Right, so if we let us run this cell, let's hope there are no errors. There's no errors. I think I made a mistake one certain name. In fact, which one second. One second. I think I made it the typo here somewhere. Yeah, well, guys, can you help me spot the mistake? One second, I think. Manufacturer. Have I misspelled Oh, right, that's a mistake. A loss. Okay, fine. No, that's the mistake. Yeah, fine, works. So, okay, let's now actually let us run the data frame to just see what it looks like right now. Uh, as you can see, it's a more readable format. It's just Nabisco, Quaker Oats, Kellogg's, Ralph's, and Purina. So you can see it literally looks in a more readable format, which is there's no longer NQK. It's now things we can talk about and understand. So it's cold. In this frame, all you can see is cold. In fact, the majority will be cold. So that's what's there. Now let us now look at now you've seen what lock is doing for a long time. Let us see what iLock is doing. Now iLock is a way of basically sort of, instead of having a logical expression, a lock is a logical expression to tell you which row to do. iLock is the index number. It's like an index location. Okay. So as you can see, this is a way of, like, as you can see 1,5. If we go back there, it's basically similar to like accessing a coordinate in an NumPy object. You're basically putting 1,5, which is your row number and recall number, and it'll output that location. Alternatively, we can basically, instead of doing that, we can do this. We can have a range instead of a specific coordinate, and it'll output everything between 1 0 1 2. Say 1 2 3. Don't output 4 because 4 is not included. So basically it takes your prints your 1 2 and 3 from this. Okay. So now we can, here is a good way of looking at what your logical, like how your logical thing plays out. Let's say if you saw here, there's a lot of cold air. What if you want to check hot, right? Well, you can see these are all your hot operations. What if you wanted to check cold? See, these are all your cold ones. So basically, what you're doing a lock here is basically you're performing a logical operation. Manufacturer, let's say manufacturer equal to Nabisco. See, here's a way of checking what you're, let's say, I want to check your Kellogg's. So you can see what is happening, right? You're putting in a logical you're asking a question to the data set and telling you what the output is. Oh, I think did I misspell Kellogg's? How is it supposed to? Oh, there are two G's. Okay, nice. See, as you can see, it didn't give me an output for this because there's no manufacturer calling Kellogg's with a single G, right? So it'll give me everything as Kellogg's. Fine. There's a lot of Kellogg's products out there. Now, so what if you wanted to be like, okay, everything that is coming out here, what if you wanted to make it a second data frame? Which is why you're basically you're basically if you assign it to a certain other data value, you'll create another data frame which is having only the Kellogg's info here. Okay. So and what is sort fiber based on fiber basically tells you that. So this is so first let's say you one second, let us. So what happened here is first thing you created the you basically took this file and you assigned this you basically assigned this output to another data frame, but you also did a second thing. The second thing was basically you're taking the fiber value, which is your fiber your fiber coordinate fiber column, and you're basically arranging them in ascending order. What this essentially means is that you are taking, let's say you're taking five. You can see the fiber value is not in ascending order. Like you can see the fiber is random, it's not ascending, but here I made it ascending. What if you wanted to make it descending? It's also possible. You can make ascending equal to false, right? And you can see what is happening here, descending order. You can see the fiber order is 14, 9, 5, 5, 4. Okay, that's nice. Now let us still similar. You can see what are logical operations that will happen with here. Logical operations here. We already saw what typical done. Let us see if you want to. We can also perform AND operation within a logical test for lock. So basically checking water or cold, and let's say if you're a consumer and you want to have certain things about a certain protein level, you say check if it's protein greater than 3. So you yesterday seeing protein 4, 3, 4, 4, 4, 3, 6, 3, 3, 3, 3. So you can see what if you want to lower the bar, what if you want to make it 4? Let's say what if you want to increase the bar, sorry. So you can see there's a lot less things coming. If you wanted to make it 5, you can, right? So if you want to make it 5, you can, and so on and so forth. You can perform a logical operation. Now, this is another thing called cascading operations. So cascading operations is basically you take you perform a lock operation here, and you perform an operation on that. So you say take this, you say sorry, you take this. One second, let's just check here, right? You take this, and you perform an operation. You perform an arranging operation on your data frame, which basically says that okay, you have okay output data frame. Now we will take it and perform another operation, which is basically what we are doing is sort values. We already saw how sort values works. Here is basically taking sugars, which again some if you have something like diabetes, maybe you're concerned about the amount of sugar. This is also something you can do. So you can see the most sugary things is your smacks and golden crisp and apple jacks, and the least sugar should be something that's a lesser sugar is something like cinnamon toast crunch, right? So now we can see that it's important in marketing applications. Let's say some names sell more better than other names. So let us check what if we sort of identify that crunch and brand are two very common names. So let us see let's see what is happening. Let's see how do you check the word crunch. Okay. So this it outputs to me all the cereal names that have the word crunch. Now there's something very very interesting happening here. This operation dot contains is a logical operation that you perform on a string that basically tells you if it has the word or it doesn't happen to have the word. Yes, if it does. True if it does. False if it does not. The question is what is this string doing here? This is very very interesting. What is happening is basically that this your data frame dot name is basically like a object. So you need to typeset the object to a string, which is why you have the string as a middleman that basically takes this object thing and makes it into a string which upon which you can perform contains operations. Similarly, we have done this for, let us, instead of that, let us do it for bran. But let us also do something called reset index. Right? So the difference that you saw here is that earlier when you're basically slicing, you're getting some random indexes here. But here your index will become 0, 1, 2, 3, 4, 5, 6, which is a much more readable and understandable format. Alright? And here same thing, watermelon has the word bran. You see 100% as bran, 100% all bran, bran flakes. So these are all the things that have the word bran. Now next thing you're doing is basically performing a deep copy. Why do you make a deep copy? Is that because if you want to, okay, this is taking some time to do. Is that, so is this cell running? So did I get timed out? Oh, I think I got timed out. So the run every second. I think what is an error that happens when you have runtime run out? Right. I think that's an issue facing from the computer from this end. Is the question of like the runtime has runtime has elapsed. Okay, fine. As you can see, the runtime is taking some time to initialize. The So fine. Let us still we can let us just because runtime is elapsed doesn't mean we can't understand the code of what's happening. So okay, let us go here. All right. So essentially, let us sort of look beyond what has just happened, which is the runtime has run out. And this is, so ideally, what you do is basically sort of restart your collab file. But ideally, I'm not going to do that considering the fact that we are sharing it live right now. But what I'm going to say still holds. Essentially, what you're doing is here is making a deep copy. And I will, since in the interest of time, I'll make a rough summary of what is going to happen. You can again explore this on your own, and I will ideally encourage you to. So now, what the essentially we're trying to do is normalize. Normalization is basically a process. Here, as you can see, data set here is that the number of cups that the company is selling is basically is not standardized. Some cups are 0.33, some cups are, you can go here, right? Some cups are 0.33, some cups are 1, some cups are 0.33. This is essentially a way of scamming by companies, while they don't tell you exactly how much they're giving per cup. It's a way of kind of like cheating the customer. So if you're, as a rational consumer, if you want to know exactly how much are they giving per cup, this is a good way of finding out. Basically, it's asking you to go row by row, dividing by the value of your cup, the cup number, basically, and scaling up everything else, like basically your calories, proteins, fat, sodium, up by that extent, depending on how many cups they've given me, right? And then I can see again setting the cup value to 1, so that we essentially have a normalized form of what your, okay, I think runtime returned, nice. Okay, runtime is returned, cool. This runtime just randomly comes and goes. Okay, so as you can see, this is what is happening. Yeah, so you can see that 3 to 14, which is basically calories, proteins, fat, sodium, carbohydrates, is being scaled up. And this is again, if you run the cell, you can see essentially what is giving me. Now it's giving a per cup what is the value of fat, what is the value of sodium, what is the value of all that. Now again, now sort of now we have an idea. Let's say we want to know what gives us the most calories because we are concerned, right? So let us again go by brand by brand. Here, what we're doing is basically you're making a different thing based on each manufacturer name. So it essentially gives me data frame where every manufacturer thing is separate. Like one is the Kellogg's data frame, one is the General Mills, one is the Nabisco data frame, so on and so forth. And then it basically replaces the values in the calories column with the row which has only with the maximum number of calories. This dot max operation basically goes down a row and tells you what is the maximum value of calorie within that row. So you're essentially telling us that okay, only return the row which has the maximum value of calories. So similarly, performing all the manufacturers, and then essentially what you're doing is concatenating them together. You're essentially telling what is the maximum calorie value for each manufacturer and sort of comparing them with each other. Okay. So if you run this data frame again, you can see that you can see that the grape nut cereal by Post is the most calorie counting. Then it's oatmeal raisin crib by General Mills, and Mueslix by Kellogg's, 100% brand by Nabisco. The least is Mapo by American Home Products, right? Which is the least calorie count. Similarly, if you instead of like maximum, if you want averages, you can basically go to here. What you're doing is basically you're going to the Kellogg's data frame. And you're performing ILOC of 3, which means basically you're taking down, you're going down the third column of every row, and you're performing a mean operation on it. So say it helps you print all your means of all your different manufacturers, and you can see Kellogg's has a mean of 238.8. So if I something a Post is 440, something like American Home something close to 100. And lastly, what you want to do is you want to sort of output your thing to a CSV file that you can use later on for data analysis. And as you can see that this data modified.csv has showed up here, which we can download and which you can use for further usage. So with that being said, we are ready to conclude this session, most of it. Is there any questions? Sure, sure, sure. Sorry, I wasn't. Was it? Oh, sorry. Was it? Was it not? Was it? Okay, sorry. I think. Am I audible now?
Yes, you are.
Okay. First thing. So the edited collab file will be sent. If the link itself will show the edited collab file. If you reload the original link, you'll see that I have filled up the file. That's how collab notebooks work. It'll show the changes that I have and transfer it to your site. Okay. So if you just reopen the link that you already been given, if you want the group to be sent again, right? The question of attendance, maybe Karthik and Ritu can clear it up. I'll just finish the technical doubts. The lock, what lock does is basically it takes a logical expression and basically within the argument and it output all the rows that satisfy the logical expression. If let's say you want to have data frame that has all the games won by CSK, and let's say a table consists of something like that, you write df.lock winner equal to CSK. If you want to check for some other, let's say winner, you want interest in RCB or loser equal to RCB, you write df.lock loser equal to RCB, right? So after that, you can of course you can always check it within your data. You can give logical expressions, and when they hold true, they'll output the required row. That is, I think that are all the doubts within this part. Can we explain the calorie protein part? So what essentially we did here was that you calorie was the third row, protein was the fourth column, third column, fourth column. So essentially you gave your you basically allowed it to take all rows, and we gave 3 and 4 in the column section to only print those rows, right? Uh, I will I will now attendance questions. I will give to Rutvik.
Yeah, we do agree that it might be a little difficult to follow along for the entire 3 hours, but we highly encourage you to go through the notes, the notebooks that we have shared. We have shared all the material that we have used for today's session on the WhatsApp groups. So do look into that. And if you have any doubts, you can post it in the WhatsApp groups. The coordinators and ourselves will be there to answer it. And yes, definitely for the upcoming sessions, we'll definitely try to stick to the time limit. Today we have exceeded the